Please, let's fill the space. Yeah? Outside? Okay, okay. The next talk is sorry, the next talk is and then the space can be between us like here. Yes, now. Hi everyone. Please, while we wait for the next speaker, don't forget that you have an Egghead subscription waiting for you tomorrow. Okay? An Egghead subscription waiting for you tomorrow. So you have access to all their courses. So you have to come tomorrow and then pick those subscriptions up as long as you have your tag. So if you don't have a tag, make sure even if you didn't register on the website, make sure you register here before you leave. Okay? And then if you have friends, because we have about 1,000 of them, and if you have friends that are not here because of work, I noticed a lot of people couldn't come in because of an office engagements. But if you have friends that will be available tomorrow, you can bring them along so they can get the subscriptions too. So it's enough, it's to get to everybody, but just make sure you're here. If you're not here, we can't give you. Okay? Oh, and we are giving the PS4 tomorrow too. I forgot to mention that. And can you ask him if he can hear us? You can hear? Okay. Okay, don't chop.
Watch up, nobody here, nobody child here. Child see there and never chop. Bug is not online, is it online? It's online, that's what it should. The rest of the guy never read this. Then we read this.
No, it's putting on some phone.
That's what it does.
Yeah, it's even better. So like you guys should also see from your stuff. Like,
see this guy. See what bug is it? Got him.
Hello, good morning.
hi, Buck. Hi, everyone. The next speaker's name is Buck Holland, and he's a developer at Microsoft. So he's basically going to be talking about a fun topic, which is on VS Code, and showing you some tricks you can actually do with your editor, which is VS Code. So, Buck, over to you.
All right, excellent. Well, thank you for having me, and good morning, or I guess good afternoon. I don't know what I think we're 6 hours, 8 hours, something like that off. So it's early in the morning here, but it's a pleasure to be with you all the way from Nashville, Tennessee. So we've got a lot to go over today, so I'm just going to go ahead and share my screen and let's get started here. So let me do that. Let's figure out how to share my screen. Technology is hard. All right, there we go. Can everybody see this? I got a little Zoom window sticking over the side, but I think we're good. Let me see if I can move this stuff out of the way. Okay.
Yeah, I think you need to zoom in a little bit.
Zoom in a little bit? Oh no, it's going to mess up my ASCII art. Let's see here. Oh no!
Yeah, that's better. Yeah, that's.
Well, I'll tell you what. Let me get through this slide, and then I'll zoom in a bunch on the next one, so we can make sure people in the back can see there. Because
okay, cool.
I know it can be hard. All right, are we ready to go?
Yeah, sure.
Awesome. All right. Well, this session is called VS Code Can Do That, and it's all about VS Code. So we're going to spend 30 minutes here just talking about VS Code, what it can do, and I'm just going to show you some things that I think are cool about VS Code. Some of them you may already know, but I think for some people, some of this stuff may be new, and you may be surprised at what VS Code actually can do, because it can do a whole lot of stuff. It's crazy. My name is Burke Holland. I'll zoom in on that part, right? Because that's the important part. My name right there. So we can zoom in on that. And I do work at Microsoft. And I work on the same team as Sarah Drasner and Brian Holt. And we work on the cloud, hopefully not the angry cloud, where we try to make the cloud a nicer place for JavaScript developers. And we use VS Code, and we work closely with the VS Code team as well. We're not on the VS Code team, but that team, we meet with them weekly. We know them well. So I would like to think that qualifies me to give a talk on VS Code. Maybe, maybe not. I don't know. Let's go through the talk, and you can be the judge at the end whether or not I've provided some value here, but I think we'll be able to look at a lot of really cool stuff. So let's just jump right into it. So the first thing that I want to talk about in regards to VS Code is the appearance. Now, you'll notice that my editor here, let me come over to some actual code. My editor here has a light theme to it. I know that's an unpopular opinion. I like light editor themes. I realize that according to the rules of science, it's not good for your eyes, but I don't care about science or facts, so I just go with the light editor theme. If you are interested in some dark editor themes, I want to show you two that are very, very really, really nice to look at. So I'm going to go to my themes here. And the first one that I want to show you is one called Cobalt 2, and that's from Wes Boss. This theme is interesting because scientifically speaking, the best color combination for your eyeballs is a dark blue background with bright yellow text. Now, you don't see that a lot because it's really garish. It's kind of hard to look at, but Wes has been able to somehow pull this off. And even I have to admit, if I was going to pick a dark editor theme, this might be it. Let me show you one more here that you got to look at. Sarah created one called Night Owl that is really fantastic. This one is just amazing. So if you're looking for that dark editor theme, and you don't want a light editor theme, you don't want to be cool like me, you can use a dark editor theme here, and one of those is a fantastic choice. So that's Night Owl and Cobalt 2. I'd recommend those. Let me go back to the right editor theme. There we go. That's the right one. All right, let's talk about a few more appearance items. Do you see this sidebar over here on the left? This is called the sidebar. We can collapse this thing with Command B, which is nice and make some more room. But by default, the sidebar shows up on the left side of VS Code. And that's fine. But I would like you to notice that when you collapse the sidebar, your code, if you watch these import statements here, your code will jump in and out of the screen like this. See how it moves like that? I don't know how well that's translating. But that's really jarring for your eyes. You don't realize it, but it actually pulls the context out of your brain for just a split second, and then you have to adjust your eyes and put your context back. So it's actually better if you go to View and then you put this thing, move the sidebar to the right. Well, now the sidebar is on the right. If you've ever used Visual Studio before, this setup will look familiar to you. For most everyone else, this is a little bit weird. But you'll notice here when I collapse the sidebar when it's on the right, look at my code. It doesn't move. It stays right where it is. And that's really, really nice for your eyes. Your eyes will thank you for this. So that's another thing you can do is move your sidebar to the right. Another thing you can do is you can adjust these icons over here with some great icon themes. The one that I use is called Material Icons. Material Icons. And Material Icons has some great icons here for the different file types. What's really cool is if you do a new file, something like, I don't know, maybe you're using Pug. And look at that. You get an actual, you get a Pug face. I don't know if people can see when I zoom in there, but that's enough reason right there to get that icon theme. It's really cool. All right, so that's that. Another one that I want to show you is I want to talk about fonts for a second. So the default font in Visual Studio Code is, well, to be honest, I'm not sure what it is, but there's another font that you can use that's called Code. So if you go out to the internet, let's go to the internet, and here's my ASCII art generator, and let's look for Code. Okay, and here we go. And you can just download this right here. And inside of this, there's a TTF file, and then you can double click that and hope there's not a virus in there, and it'll install it into your computer. And then once you have that font installed, you can use it inside of VS Code. So I'm gonna collapse our sidebar for a second, and I'm gonna go to User Settings. You'll see me using a lot of keyboard shortcuts. I'm not gonna say all of them out loud. The one I just did was Command, comma, to User Settings. You can also do that by going Command-Shift-P or Control-Shift-P if you're on Windows and just looking for User Settings, Open User Settings. So once you're in your user settings here, you have two different ones. User Settings is global, Workspace Settings is just for the current project that you're in. Most of the time you'll put these in User Settings. So what you can do here is you can add in a setting for Code. Right here, setting your font family and then your font ligatures as well. Now, if you don't know what font ligatures are, they are a way to represent symbols that we use in code that are comprised of multiple or compound symbols in one symbol. So let me show you what that looks like. I'm going to click Save here. And you'll notice that the font changes slightly. You may not have seen it. It happens pretty fast. But where it'll show up, let's go to this file here. And let's look at something like, let's just come down here and do, let's say we have a function. We're going to make a new function. Let's just do that. I'll tell you what, let's go down here to the bottom. Let's just do a new function. Okay, and then we could do a function here. And then we can do a fat arrow. So you'll notice that when I did that fat arrow there, I got an actual fat arrow, just like that, which is pretty cool. It also works for things like equals equals. So if you did equals equals, you get a double equals. And if you do equals equals equals, you get a triple equals. And you can do not equals, and you get a not equals. And of course, this works for people that are not using this font. So if you use Fira code and then you give it to someone who doesn't, it still works for them in their font. They just see the 3 equals and you see that nifty triple equals. So that's Fira code and font ligatures. A lot of people use font ligatures. You don't have to, but it's a lot of fun and it adds a lot of character to your editor. So that's pretty cool. How's my Christian? How's my font size here? Are we good? Can everybody see
good.
All right?
It's good, yeah.
Excellent. All right. Well, we've spent enough time. There's a lot of different things that you can do with the appearance. You can change the cursor style. You can make it so your text explodes when you type. You can do all sorts of stuff. But we don't have a whole lot of time, so I want to move through some other stuff. And don't worry if I'm moving quickly and you're forgetting some of these things. You'll forget most of them, and that's okay. I'm going to give you one place at the end where you can go to learn about all of these things on your own time. So I'll give you all of the tips that we're going to do here today, plus a bunch that I just don't even have time to get into. All right, so let's move on. And I want to talk for a second about Emmet. Now, a lot of people will be familiar with Emmet, but some people won't be. So just to go over it very briefly, one way to create a div is like this, right? But it kind of gets a pain when you're creating these things all the time, those carrots there. So what you can do instead with Emmet is just type div and then hit tab and you get a div. And then you can do things like div.main will give you a class of main with maybe an ID of body, something like that. So Emmet just makes it faster for you to compose HTML. And I mean really fast. You can add an entire page of HTML just by typing bang, and then you get a whole page of HTML. And you'll notice that you get these tab stops in here, so you can move through these things like this. And then you can come down and start writing in your body. Now, there's a whole different list of Emmet shortcuts. There's an Emmet cheat sheet that you can check out. If you just Google Emmet and Emmet cheat sheet, I'm not going to go through all of that because it can get really, really complex. You can have, if we look at something like this right here, I mean, that's just a lot of code. And you get a bootstrap nav bar from that, but when you just look at it, if you don't know Emmet, that doesn't make a lot of sense. So I don't want to go over all the syntax. I just want you to be aware that this does work. Now, for those who already knew Emmet, you're like, I already knew that. Okay, all right. So maybe you didn't know that Emmet can do this. What say we had an image, something like this. And in that image, let's say our source was this file here. Okay. Now, one of the things that we want to do when we have an image is we want to specify the width and the height of our image. And we do that because if we don't, the browser doesn't know how much room to reserve on the page. And so when the page loads, it won't reserve any room at all. And then when the image jumps in, the whole page jumps. So we want to put a width and a height on our images. That's kind of a pain because we don't know what the width and height of this image is. So one way for us to find out would be to just go to the image, which is here. That's my dog Grover. He says hello. And we can see it's 640 by 640. But we don't want to be looking up all of our image sizes all the time. That's a pain. So what we can do instead is we can just come to the end of the line, open our command palette with Command or Control-Shift-P, and we can say update image size. It's part of the Emmet commands here. And when we do that, boom, Emmet automatically knows how big that picture is and can update your images. And furthermore, this works in some places where you might not expect it. Places like, check this out. Let's say we add in a remote image, right? This is an image that's out on the internet. Let's check it out. There we go. Now we can see from this, I've got an extension installed that actually shows me in the pop-up here how big these images are. But again, we can let Emmet do the work here by saying Command-Shift-P and update image size, and boom, it can do that. It's pretty amazing. Now, it also works in CSS. So if you were using a background image in CSS and you wanted to automatically get the width and height, it's another place where it's kind of a pain. You can do that. The same update image size works in CSS when you're setting the background URL for an image as it does here in that image tag. It's pretty cool. One last thing on Emmet, it can also do math. So in case you don't know what 1 + 1 is, you're having a rough day and you just can't be bothered to do math, you can just highlight that, say math. And it will evaluate the math expression for you. So it's just a nice way to do calculations inline without having to jump up and open your calculator app or use your brain on a day when you're just not having it. So that's Emmet and some of the different things that you can do with it. It does a whole lot more than that. I just wanted you to be aware. Of course, it also works in CSS. So if we had something like the body, and let's say you wanted padding, but you don't know, you just hit P and tab and you get padding. If you hit P5, you get padding 5 pixels. So again, just be aware of all the stuff that Emmet can do, and then you can go take a look at that and dig in there. Let's talk about Prettier for a second. I've got some React code here that I've written, so you know that I'm very, very smart. And in this React code that I've written, I've got a lot of different formatting here. Well, this one's actually formatted pretty well, but let's say we had something up here where we had like, we do this a lot. We might have something like, let's do component did mount. And then inside of that, maybe we have like, we're doing some sort of fetch. So var result equals fetch, right? And then we've got some URL, with some ID, which then returns a promise, which has some results in it. And we take that to JSON. Actually, we don't need this. I think we can just do this. And then we can do then, and then we take that and we want to pull that JSON in, and then we actually want to return the JSON right there. Now, the thing about this is that some of these times these promises get long and we're not really sure where to put them. So sometimes we're like, well, I'll break it here and then here, and then someone else comes along and they start breaking their promises here, and then someone else puts them all on the same line, and you're like, of course, if your promises are lengthy, then this gets just magnified. So one of the things that you can do is install an extension called Prettier. So if we look for the Prettier extension, it's right here by Esmond Peterson. It's one of the most popular extensions in the marketplace. And what it does is, let's go here and say Command-Shift-P, and we'll say Prettier. We'll just say format document. And you'll notice that Prettier automatically formats this for us based on some rules that have already been defined. Now, these rules can be defined in a Prettier config file. You can even define rules in ESLint and have Prettier observe ESLint, which it does by default. So let me show you how this works in a more complex example. Let's say you have a file like this. Actually, let's do a different one. We've got one that's in bad shape here. This one right here. Now, this file has a lot of red squigglies in it because it's using double quotes instead of single quotes, and the TSLint is complaining about that. And also, it has no semicolons. So whoever wrote this JavaScript is a no semicolon person. So if that's you and you are like me and you're a definitely semicolon person, or that's just what your project calls for and your team requirements are, you can just say format document and watch this. Boom, all the quotes get changed and the semicolons are back. So that's what Prettier does for you. And of course, you can set that automatically instead of saying format document all the time. You can come to your user settings. You can come down here to the bottom and you can say, let's add in a setting for editor.format on save. And we'll just set that to true. And now Prettier will just fire every single time you click save. Prettier will fire on your document. Now, if you get into a situation where you don't want Prettier to work, because sometimes you want it on and sometimes you want it off, there's an extension called the formatting toggle. And the formatting toggle, all it does is turn off and on that automatic formatting. So you can just say toggle format on save like this. Let's say right there, and then it'll go off, and then you can toggle it back on again. So that's how you can control the format on save to either make your code prettier or not make it prettier, depending on whether or not you want to use that. So that's Prettier and super helpful. We've got some snippets here. I want to kind of move through and talk about some more advanced things. Let's talk about type checking for a minute. Here's a JavaScript file that's got a ton of mistakes in it, but they're not actually, they're not readily apparent. If you looked at this for a second, you'd probably pick them out, but I write JavaScript like this all the time. But one of the things that we can do is we can actually use the TypeScript compiler to check this file for errors. So we can say @tscheck, and we get squigglies. And if we press F8, it will move us through the squigglies. So let's start with this one up here. I moved down too far. So right here, cannot find name Rick. All right, we can fix that. Okay, cool. Then we'll do F8 again. Cannot find X. All right, we'll fix that. F8 again. Property blog does not exist on type console. Did you mean log? Yes, I did. I wish blog was a method on console, but it isn't. So I use type blog like that. So that's how you can use the TypeScript compiler to check your code. Notice we're not even using TypeScript here, but we can still use the compiler. Now, if you wanted to use something like this at a project-wide level, you wouldn't do this in every file because that just is not going to fly, having this whack tscheck at the top of your file. So if you come here to your user settings, you can do, there's a setting called implicit project, let me try that again, implicit project config check.js, okay? Not terribly intuitive. I don't if somebody hadn't showed me that, I don't know that I would have thought to look for that particular setting, but there it is. And we set that to true, and then we'll get that same TypeScript checking on every JavaScript file in the project, every single one. And you might want to add that to workspace settings instead of user settings, so it's on a project basis. All right, let's do some more advanced things here. Let's get into it really. So let's take a look at something like, I'm going to move over to this React app here. So this is a React app. Let me fire it up. Let's just do npm start. And this is really the simplest React app you can possibly have. And hopefully it'll fire. Here we go. So this is React. You might recognize this as Create React App. And one of the things that React devs love to talk about is how it's only JavaScript, so you can do cool things like break inside of templates. Now, normally if you were going to debug a React app, you would do it just like this. But I would like to propose to you here today and now that there is a better way to debug your front-end apps. It's actually easier to debug in the same place where you write your code. Writing code in one place and debugging it in another is not the end of the world, but it's just a better experience. And VS Code can do that. So let me remove this. Let's continue on. Let's come back to our editor here. And what we want to do is we're going to come over and we're going to add in a debug setting here. So I'm going to click on this little gear up at the top. And I've got the Chrome debugger installed. So that's right here. That's an extension. So we'll select this. And the Chrome debugger is going to come over here and it's going to try to figure out what our settings are. Well, this isn't exactly right. The URL of our app is going to be 3000. And then our workspace folder is, if we come over here and look, we are in SRC. That's where our code is. That's what it wants to know right here. So let's go ahead and save all this. And then now in our debug, we've got a new setting here, launch Chrome against localhost. So I'm going to go ahead and fire this up. And when that fires up, what you'll notice is we get another instance of Chrome. See how there's two now? This was the first one we had. This is the one that VS Code launched, but it's running that same React app on port 3000 here. And now, check this out. We can come back and say app.js, and let's remove all this noise from the top and the bottom. Add a breakpoint right here. Go ahead and refresh. And boom, now we're editing our React code right inside of Visual Studio Code, which is amazing. And this is a far better debugging and editing experience, at least in my opinion, because all of my code is right here. And if I change my code, it still works, okay? And so just a different way to debug your applications, and be aware that Visual Studio Code is very good at debugging front-end apps. It doesn't really care where your app runs, as long as it's running on some sort of node process, which it is, it can attach automatically to that process and help you debug. So that's pretty cool. That's React app. Let's jump over and look at something like an Express app. So this is a very simple Express app here. I'm going to go back to my React app. Let's go ahead and kill this. I'm going to pull up the terminal and kill this here as well. If you didn't know, VS Code has a full-on terminal, so you can do cool stuff like this and impress your friends. There you go. Look cool. Like when people are looking at you, what are you doing? I'm hacking the internet. Leave me alone. I'm busy. Go ahead and close this out here. All right, so let's move over to our Express app here. Where was it? There it is. Now, with an Express app, Express is interesting because you can actually run this without any sort of launch configuration at all. But what I want to show you is the built-in support for Docker that you can get with VS Code. So if you've not used Docker before and you're not familiar with what it is, just understand that Docker is kind of like an EXE for your web apps. You know how an EXE, you have everything that you need inside of that EXE, and then when you run it, it just runs. It has all of the dependencies that it needs. It has everything. So Docker is the same way. You basically create this container which has in it everything you need. It has Node, it has any of your dependencies installed, and then you can just throw it up on a server and it just works. It's kind of magical. So let me show you how you can use Docker inside of VS Code. I'm going to come over here to the Docker extension. So again, these are extensions you can install. This one's from Microsoft. Straight to you with love. And you need to have Docker installed on your machine in order for this to work. And I actually don't have Docker running, so I'm going to go ahead and fire that up here. Now, in order for us to run this application, this Express application in Docker, we actually need to add some Docker files here to do that. But we don't know anything about Docker files because we're Burke, and Burke learns very slowly. So what we can do here is come and say Command-Shift-P, and then we'll say Docker, and we'll add Docker files to Workspace. Now watch this. It's going to ask us what our runtime is. We're going to say node. What port are we listening on? 3000, that's right. And boom, all of our Docker files just got added to this application. We got the Docker compose, we got the Docker file, and we've even got a Docker ignore file. So now that we've got this, we can run this container. So let's do Docker compose up. And we got two choices. We can compose debug or compose. Let's just compose for the moment. And that will go ahead and build our container here. And if we go out to our web app here and run this, we're now running our Express app on port 3000. Over in our Docker container here, you can see it's running right there. It's got the green dot. We could right click and say show logs, okay? And that's gonna show the logs. If I come over here and refresh a couple more times, here's all the logs. Even better yet, we can attach our shell and we can look at all the files inside of our Docker container. So this is amazing. We don't know anything about Docker. All of these are commands on the Docker command line, but I cannot remember command line switches and flags. So this makes it easier for me to actually work with Docker. And if I can do it, anybody can do it. So let's take another look at another thing you can do with Docker in VS Code. I'm going to go ahead and stop this container here. I'm going to close this. And I want to show you something really interesting. If you click on this gear here, let's add in a launch configuration for Node. So this is a simple, this just runs our Node app. And you can see Visual Studio Code is smart enough to know how to run an Express app. It configures it for you automatically. But watch this. We're going to click Add Configuration, and we're going to say Docker attached to Node. And now we have a Docker debug configuration. And it knows all about our Docker setup because it's read our Docker files. So what can we do with this? Well, watch this. Let's save our launch configuration. Let's do Docker compose up. And this time we're gonna choose the debug file. I'm gonna show you why this file is here. Let's go ahead and do that. And that will go ahead and run our debug build. That's running. Let's go back. We can see we should be able to see our container running here. It's right there. And now watch this. Let's come over to our index file. Let's drop a breakpoint here. We'll come back to our debug and we'll do our Docker attached to Node. And go ahead and hit that. Let that attach. Now come back to our application, refresh. And we are now debugging our application inside of the Docker container, which is amazing stuff. If you've worked with Docker before, you know that it can be really, really difficult after you get these things inside of containers to work with them. So this is just kind of magical. And now that we've got this container, of course, we're ready to deploy this. We can say right click, let's find our image up here. We can right click it and say push like this, and it will push it up to Docker Hub. And it does need me to log in here, but we can push it up to Docker Hub, and then we can pull it in from Docker Hub and host it anywhere. Places like Azure, or you can even host it on Azure. All of those will work with Docker. Now, let's look at one more thing because we got a couple more minutes here. There are a ton of extensions for working with Azure directly from within VS Code. There's app service for working with any sites that you have hosted. So here you can see, or you will see here, all of my subscriptions and all of my different sites. You can build serverless functions directly from VS Code, which you see here. So you can start a new function project. You can run them locally. You can debug your serverless functions locally. And then we have one for storage. One I want to look at is called Cosmos DB. Now, Cosmos DB is a database that Azure provides that is NoSQL, and it's multi-model and multi-schema, which basically means that you can create a NoSQL database that's either has a Mongo API, has the Gremlin API, has the Cassandra API. So you sort of pick your API, and then the extension allows you to get to that data. Now, what's interesting about this extension is that it's not just Cosmos DB. This extension will actually attach to any MongoDB database anywhere. So I've got mine attached locally here to my local host, and you can see these are the different databases that I have. Now check this out. If I right-click this and say connect, we're connected. Okay, cool. I'm gonna now come over and I'm gonna say Mongo Scrapbook, new Mongo Scrapbook. And now I'm gonna hit DB dot, and we can see I get IntelliSense for all the collections I have, and then I can do find, and then I can do Command P, execute MongoDB command, and boom, we get back all of the records that we have in this database. So if you're working with any sort of MongoDB, you don't have to download a third-party tool to work with that database. You can query, test, do everything you need right in the same place where you write your code, which is so nice, so wonderful. All right, I told you I'd give you a resource. We got 2 minutes left, and we got so many more things that we could go over here. Let's go back to our slides. We didn't get to NPM tools or some of the other stuff that I wanted to get to. But since I don't have that much time, let me just leave you with, let's go back to Chrome here. If you just go to vscodecantdothat.com, you'll see all of the tips that we did today. I share a different tip every Friday. So we've got all sorts of stuff here from how to use live share to how to create an interactive scratch pad, how to do serverless, some of the visual tweaks we talked about. In addition, we also give you a 2-minute video every month that shows all of the release highlights for the next release, because Visual Studio Code moves really, really fast in terms of adding features. So it iterates so fast that it's hard to keep up with what's new. And Brian Clark does that every month right here on vscodecantdothat.com. So that's all the time I have. I'm actually 1 minute early. I don't know if I was supposed to leave time for questions, but I didn't. So thank you very much.
Hi, thank you so much, Borg. I don't know if you can still hear us, right?
Yes.
Yeah, can you put on that your host mask so we can say hi to it?
Absolutely.
Yeah, so questions. Do you have questions for him?
Sure.
Questions? Come get him.
Hi, boy. Yeah. I cannot change my default on VS Code. Like, if I don't want to use Chrome, how can I change it to Mozilla Firefox?
How can you change the default browser that it opens?
Yeah.
That's a good question. I don't know the answer to that right off the top of my head. I would have to go and look. Google would probably be your best friend there.
Hello.
Hello.
Yeah, I have a problem with VS Code Lifestyle. Okay. After closing it and launch another application on it, it was still loading the previous one.
Did you say that was with live share?
No, I said VS Code Live Server.
Oh. So are you using a live server plugin extension?
Yeah.
So for live reloading?
Yeah.
Yeah, I'm not. So can you restate the problem again? You said that it's. What did you say there?
I used it to load a web page. Okay. Then after shutting down the process, then to load another web page, it was loading the previous one. Okay, you can answer that.
I think.
Yeah, I think he's saying. So assuming I launched a live server with localhost 3000, and then I shut down VS Code, and whenever I visit localhost 3000, it seems like VS Code has just seized that port forever.
Yes. I've actually noticed this myself with a couple of different processes here, and really the only tip that I have for how to handle this is to learn how to kill that specific process. So basically, I've just sort of memorized LOSF-I TCP : whatever 3000, which kills that particular process. But yeah, I've seen the same thing, and I don't have a good answer for you other than I share your pain.
All right, Buck, I have two questions. So the first question is, when you're using your terminal within VS Code, I think after some time you start to experience this kind of junky experience where it kind of slowed down in a way. So I don't know, is there a particular way to optimize performance for that? That's for the first question. And then the second question is, are you trying to eradicate Sublime from the market?
All right, so let me get the first question right. You said the first question that the extensions were making it slow?
The terminal, running your terminal within VS Code. After some time, it starts slowing down the whole experience, like the VS Code, the editor itself. How do you optimize for performance?
Yeah, so usually that's caused by extensions. And there is there's a process explorer that you can see inside of VS Code, and it will show you the processes that are running and what memory they're using. So you can see there's the main process, there's my window, and any extensions I have. So it'll show you what's getting usage. I don't know if you watch this or not, but that's what I would do when it starts to slow down, number one. And then number two, you want to start looking for these things down here. So these things are built in, these electron stuff. If that seems to be your problem, then that's a GitHub issue. If you could open please on the VS Code repo. But my guess is you're going to have some sort of extension that's up here at the top. Does that answer that question?
Yeah.
Okay, and then the second one was, are we trying to replicate Sublime?
Are you trying to eradicate Sublime from the market?
Oh, no, we're not trying to do that. So here's the thing. When it comes to text editors, because I asked the VS Code, or Amanda Silver, who's the VP on the VS Code team, I said, why do we need another text editor? We have plenty of text editors. So here's the thing about VS Code that makes it a little bit different. VS Code is a text editor, but it's also as much of an IDE as you want it to be. So as you can see, you can just edit text, or you can query a database. It's up to you. And you can add that stuff in. So what VS Code is trying to do is it's trying to sit in the bridge between full-on IDE, which would be like Visual Studio or Eclipse, something like that, and a very lightweight and fast text editor. So no, the goal is not to eradicate anybody from the market, but to just experiment and see if developers would appreciate a text editor that could grow and do a whole lot more if they wanted it to. And it turns out, yeah, we like that.
All right, thank you, Buck. Thank you for that presentation.
Thank you so much for having me. It was an honor to be here this morning. I really appreciate it.
All right, my regards to HostJS.
Bye, everybody.
Bye. What? It's back. Did you hear what I said? Okay, it's gone. All right. Yeah, how many of you follow HostJS on Twitter? That's a very, very ridiculous handle. All right, so is Jem around? Yes. Okay, so for our next speaker, how many of you watch Netflix here or subscribe to Netflix? All right, okay. So our next speaker is not here yet. Okay. All right. Since our next speaker is not yet, is not around, so now we still have one more day, right? This is the first day, and we have another day tomorrow. Many of the gifts that we'll be giving out tomorrow. Yes, because we know that we are Nigerians. We understand how these things work. Come the first day, second day, we might see only 2 rows here. Yeah, so we have so many. We have Egghead subscriptions. We have front-end master subscriptions. How many of you know Tyler McGuinness? Yeah, we have subscriptions from Tyler McGuinness too. It's funny because I'm subscribed to all these platforms. And then, as from tomorrow, I'm just going to have them for free. Yeah, I'm going to stop paying for it because we have a lot of like coupons that we just use for everybody, or for the guys that are here tomorrow. And we have some books. Yeah. We have some books from Aaron for progressive web apps, how to design things. There are like 6 different types of books that I brought when I traveled the last time, and they were from some of the authors that are speaking today. And I'll bring them tomorrow. They're about 50 or 60 in number. So, yes, hard copy. This is not PDF. Hard copy. Yes. Is he around yet? All right, so our next speaker, I don't know if it's not around yet, right? But then let me just give you the short bio. He's a senior software engineer at Netflix. And then it's funny because, CodeBeast talked about GraphQL versus REST. And then Netflix was working on a technology that was supposed to be what GraphQL is. But they called theirs Falcor. How many of you have heard about Falcor or tried to play around with it? Yeah, but then Facebook released GraphQL to the market, and then nobody knew about Falcor. For some reasons, everybody just like started adopting the implementation of GraphQL, and now we have GraphQL all over with so many companies, Shopify, Opera, so many companies using GraphQL. So that's just a brief intro. And then he's a member of the Bird Gang too. So I just want to say that. So when you see him, you not be scared. Member of the Bird Gangs, senior Bird Gang member, because he's very full, very full. Is he around now? Okay, so he's going to be talking about how things work. That sounds abstract, right? How things work. What things exactly? You're going to understand in the session. Even me, I don't know the things. Oh, God, very interesting. All right, Jem, are you ready? We can hear him. Hey, Jem. Are you? Oh, okay, you're on mute.
How's that?
All right, I think we can hear you now. Can you hear us?
Is anybody talking? Because I can't hear anybody.
All right, so we can hear you now. Okay, so you can start.
One second. I think you can hear me, but I cannot hear you, so just want to double check.
Yes, we can hear you.
All right. That's better.
Hey, Jim.
Yeah.
Yeah, you can start.
Okay, awesome. Making sure everybody can hear me. Let's go ahead and share that screen. All right, are we good?
Yes.
Can you hear me?
Yes. Take it
Awesome.
away.
Sorry for the delay. It is, I'm sure every speaker has come on and said this, but it is 6:30 in the morning, my time, and there's no one here. I'm here at Netflix because I want to make sure the internet was good. And yeah, I don't have any jokes this early in the morning, but it is lonely. After this, I will show you the empty room that I'm talking to. But morning, afternoon there. As I was lovely introduced, thank you for that. My name is Jem. I work on Netflix at Netflix UI Engineering. And today I want to talk about something a little bit different. The last talks have been fairly technical, and they're all much better engineers than I am. But today I want to talk more about the process, about what engineering is, what it looks like, what is performance engineering to everybody else. Because to me, it's this idea that engineering is not just about butts and seats, as people say. It's about the people. At the core of every piece of code, every piece of software we write, it's the people that make all the difference. In fact, one of the mantras here at Netflix is that we believe in people and not ideas. So that's funny because most people don't think that. Most people think, oh, I have a good idea. Oh, I have a lot of money. Oh, I live in the best city because this city is the one with all the tech people and are really smart and all these things. And so my idea is going to succeed, but that's not true at all. In fact, there's more people in this conference than there are in all of Netflix. There's more engineers at this conference than there are at Netflix. We have not that many engineers for our reach. And what I want to talk about today is, how do we do that? How is it that we're a relatively small company and we have such a global reach where Netflix is 34% of the internet's traffic? How is that possible? Today I want to talk about 3 ideas. Actually, I should say 3 problems. These were hard problems. These were $1 million problems. I want to talk about the Light project. Talk to you about faster things. And I want to talk to you about Atticus. But mainly what I really want to talk about is the people behind the ideas. Because it's not enough for me to say, oh, we had this problem here at Netflix and then we solved it because we have a lot of engineers and all these things. But no, these problems were solved by just 3 engineers. 3 individual people that thought a little bit differently about the problem, that challenged the status quo, that said, this is a hard problem, but you know what? I can solve it because that's who I am. But really, I want to talk about the difference between science and art, because software engineering is somewhere in between. And really, at the core of the talk, what I want to talk about is how things work. My name is Jem Young. I'm a senior software engineer here at Netflix. I say here, but you can't see anything. But I'm here at Netflix in California. And it's funny because people always say, what makes a senior software engineer? Senior. I know, senior software engineer is a bit ironic because my last name is Young. So even when I'm 70, I will probably still be a senior software engineer of some sort. Hopefully that joke lands. I can't hear if you're laughing. I'll just assume you're all laughing really, really heavily, and I'll pause for that. All right, okay, thank you. I can hear it now. It's really hard to tell a joke when there's no one around to laugh. And other than me and my cat and my fiance, there's no one really to laugh at all my jokes. So I appreciate that. But what is a senior software engineer? Well, a lot of people think, hey, senior software engineer, that means you probably write a lot of code. You probably write way, way more code than a junior engineer. Well, I try not to, if at all possible. And of course, you know, there's the rock star engineers that I've never met, but apparently all of the companies in the Bay Area are only hiring rock star engineers. But that's not the case at all. And in terms of senior software engineer, you don't define it by lines of code. In fact, I spend most of my day trying to write as little code as possible. That's true. I strive to be the laziest engineer at Netflix. I don't want to write any code if I can. Or if there's a bug fix or a feature to get built, I want to write the smallest amount of code as possible. And this seems a little weird, but that's the way it should be. In fact, one of my managers once told me a good quote. He told me that the more senior you are, the less code you write. And ideally, you would look for ways to avoid writing code because that's where the bugs come from. It's true. I have many war stories to tell you, maybe some other time. But I don't want to write any code if at all possible. Or I want to write the smallest amount of code because I can understand the changes. I can understand everything that's going on. It makes it easy to refactor in the future. So if I'm a senior software engineer, but you can't define my performance by the amount of code I write, then what is engineering performance? Let's not talk about engineering performance. Let's talk about the people behind it. Let's talk about human performance. Let's talk about what makes one person excel, what makes them a high performer. And to do that, I want to tell 3 stories. The first story is, it's about the Light Project. And of course, I can't talk about the Light Project without talking about the person behind it. So, meet Tony Edwards. Tony is a senior software engineer at Netflix. And Tony, he had a hard problem. You see, he worked on Netflix.com, the landing page. If you go to Netflix.com and you're not a member, you're gonna see something like this. And to a lot of people, it's like, oh, it's a web page, right? It's a website. Anybody ever heard that? Oh, all you do is build websites? Anybody heard that? I've heard that like my whole life. And obviously, I would argue that it is one of the more difficult things you can do. And Tony understood this. Tony understood that if you're building a site that gets millions and millions of visitors, there's this complexity to it. Because at Netflix, we run a lot of A/B tests, and we've had tons and tons of engineering hours spent making Netflix.com as fast as possible. So when he was tasked with the project of making it faster, that's not that easy. You can't just look at some code and say, oh, I'm going to delete this code and boom, I'm done. No. So Tony was on this team, and I was part of this team as well. I had the honor to sit in and throw bad ideas, which got rejected. Some of them were okay. But we tried lots of different things to make Netflix.com faster. We tried different compression. We tried comparing Brotli versus gzip. Didn't do much for us. We tried different methods of compressing images. So instead of progressive JPEGs, we tried PNGs, SVGs. We tried lots of different, even obscure ways of compressing images, and it didn't do it either. Then I thought, how about I preload my JavaScript? So that way, nobody is waiting for the JavaScript to load. They come to the page, the JavaScript's already queued up. No, that didn't work either. So I probably should have mentioned this about Tony, but Tony is a car person. He loves his car. This is his car, Pegasus, a great car, Mustang 5.0. It's a good looking ride. But one thing that everybody knows about, or what you can say about car people, is that they know it's not the size of the engine. It's the weight of the car that matters far more. In fact, Colin Chapman, founder of Lotus Cars, he once famously said, simplify and then add lightness. So Tony used this innate ability, this love of cars, and he applied it to engineering. And he thought, I have this idea. Because when you're talking about speed of a page, you're talking about performance, it's not the loading time, it's not the rendering time, it's not the painting time, it's the scripting time. The scripting time is almost always going to be the slowest part of your page. So Tony said, well, if the scripting time is so slow, why don't we just take it out? And that's how he came up with the Light project. Tony said, all right, everyone, let's take it all out. I said, take out what? He said, everything. I'm like, what do you mean everything? He said, everything. So let's take out every library we didn't need. Let's take out every bit of CSS we didn't need. Let's take out every bit of HTML we don't need. And let's strip it down to its bare minimum. You know, old school JavaScript, no frameworks. And it worked. It was this radical idea, but we believed in Tony, and it worked. It made Netflix.com 50% faster. 50%. We still use React on the server. We use React to render the page, but we don't send down the React library. We don't send down Lodash. We only send down the bare essentials, the bare minimum needed to execute that page in vanilla JavaScript. And it worked. An idea is so simple. So instead of adding more libraries and adding more complexity, we just took out the complexity. We made it as simple as possible. And the lesson we can learn from Tony and the Light projects and making Netflix.com 50% faster is it's the code that we don't write that often makes far more difference than the code that we do. And that's a hard lesson. That is a lesson that a senior software engineer would know, but other people, maybe less experienced, wouldn't think of that way. But that's something unique to Tony, and he had the latitude here to try something, this audacious experiment that worked, because we all believed in him. So that was Netflix.com. That runs on thousands of devices, but let's talk about something a little more obscure, something that you may have used, but people don't think about a lot. I want to talk about TVs, Netflix on TVs. But really what I want to talk about is the Faster Things project. Possibly one of the best names for any project out there. I don't know about you, but I'm a big fan of Stranger Things. It is delightful. A great show. Sorry, I will talk about Netflix shows all day. During the Q&A, just ask me, I have opinions on all of that. But part of what makes Netflix so good is the compelling reason that I can just turn on my TV and watch a movie or a TV show at any time. And most people don't know this, but TVs are really, really, really slow. In fact, my cell phone probably has 10 times the processing power of any TV. Yeah, we don't think about that TVs are slow. So we had this problem. TVs were a bit too slow. So that came upon this person. Meet Joey Cato. Joey is a senior software engineer at Netflix. And Joey had a hard problem, similar to Tony. See, the TVs, sometimes they were crashing. And I don't know if you've ever seen a TV crash. I've seen many of them. It's not pretty. And sorry, jumped ahead a bit, but I should have described Joey a bit more, because to talk about this project, I need to talk about the person behind it. And Joey is a hacker. And no, not the kind you see on the media as, someone wearing baklavas, hacking on is that like a 2000 year 2000 MacBook? I don't know. No, Joey's not that type of hacker. Joey is a tinkerer. In fact, Joey is so good, he's won Netflix Hack Day 4 times. 4 times. And I don't know if you know anything about the caliber and quality of engineers here at Netflix, but winning 4 times is a very difficult proposition. But that's the type of person Joey is. Joey likes to tinker. He likes to think outside the box. And he had this problem with the TVs. They're crashing because they're so slow. And when a TV crashes, it's really bad. In fact, well, what is even going on there? That's a crashed TV. That's a bad experience. When you're sitting down with your friends and family, your cat, you don't want this to happen. And there's a lot of these happening. On some of the lower end TVs, the TVs kept crashing. So someone said, hey, Joey, you look like you like a challenge. He said, yeah. We need to fix this. We need to fix this problem. So Joey thought about it. He thought, I've got this screen. We call it the plan selection screen. It's where if you're signing up for Netflix, you pick a screen and you join and you continue on into your payment method, et cetera. And it was nice and shiny and pretty, but Joey thought a little bit deeper. He thought about how things work at the core. He thought, to get a nice smooth transition from this screen to the next, and it's buttery smooth and it slides over and it looks good and everybody's happy and designers are happy. The only problem with this is, remember what I said earlier? TVs are really, really slow. In fact, when we talk about video memory, did you know an Xbox 360 only has 512, somewhere around there, of video memory? My phone has more than that. Your laptops have more than that. So not only do we need to run Netflix, we need to run the TV, we need to run all the apps, we need to run the Ethernet and wire. So we were running out of video memory and it was crashing. And Joey understood this. Joey's a UI engineer, but he understood that low level, deep down core of how TVs work. So Joey thought, hey, instead of rendering both screens at the same time and transitioning together to make it look nice and smooth, why don't we just render one screen and then render the other screen? A radical idea. And when he tested them out, it worked. It was so much faster and TVs crashed less. And you're probably thinking, hey, Netflix, we have pretty good design. No, we have beautiful designs. I'm not gonna lie, I'm really proud of our design team. And you think, well, if we're building something that's not as pretty, but it's faster, do you think designers are gonna go for it? Yeah, they do. Because we care about what's good for everybody around the world, not just being pretty. I mean, I care about being pretty. Look at this beard. Again, I assume you're laughing because I can't hear you, or you're just admiring my beard, you're in awe. But it's interesting because when we talk to the design team and we approach this radical idea, like the site's not going to be as smooth and pretty and the animations aren't going to be as good, but we're going to crash less and we're going to have a better product all around. The designers, they're like, yeah, because that's the kind of culture we have. We want to empower engineers to make these decisions and then share them broadly. And we all agree that we want to do what's right for the end user all the time. And what we learned from Joey is you need that freedom to explore. You need that freedom to try radical ideas that no one ever thought. No one ever thought if we don't make these smooth screen transitions, it'll prevent video crashes. These ideas are so opposite of each other, but that's what makes a good engineer, is they take their experience, just like Tony did with his car, and Joey did with his ability to tinker and hack and learn deeper. That's what makes good engineers. So that was the Faster Things projects. And the Light project and the Faster Things project were impressive. They really changed how we thought about UI. They changed how we thought about the problems that we have to solve every day. But now I'm talking about something a little bit different. I want to talk about Atticus, the Atticus project. And again, I cannot talk about any good project without talking about the engineers behind it. Meet Aishwarya Rajmani. Aishwarya is a senior software engineer here at Netflix. And Aishwarya had a problem, as all engineers do. You see, Aishwarya worked in this complex, massive node application that we know as Shakti. And Shakti it's the gateway to pretty much the rest of Netflix. If you use Netflix on a mobile device or a web browser or anything like that, you're going through Shakti, which is a really complex node application. The thing is, Shakti is just one part of this massive, massive ecosystem that we know as Netflix. This big system of complex microservices and interconnected dependencies and lots of names. And I don't even know what most of these are, honestly. I know what Shakti is. That's what I work in. But Shakti was dependent on all these services to serve out the right content. And one of Aishwarya's job was to make sure that we don't break Shakti. So she had to oversee a lot of tests. A simple test would be something like this. We call it sign up payment selection, yes, for Spain. And it's just moving from one screen to the next, just making sure the experience isn't broken, because we have 30 some odd engineers on our team constantly pushing, constantly breaking things, mostly me. And Aishwarya's job is to make sure that the site didn't break. The problem was, not in production, but in test, the site was breaking. The tests were failing. And the problem when you get that much noise is that people stop watching them. You stop ignoring tests. Why have a test if it's gonna be flaky half the time? We did a little better, but at one point, our APIs were so unstable that only 88% of tests passed. That means if I ran 100 tests, 12 of those tests would fail, not because the test itself failed or the code failed, but because one of those many downstream dependencies failed. So that's not good. We want people to write tests. We want people to believe that when their test fails, it's because the code, but people stopped looking at them because we had so many failures. And it's not just one test. There are thousands of tests. At any given time, there are thousands and thousands and thousands of integration tests running constantly on Netflix. Someone once told me that in a day, we probably run a couple million tests across all our devices. So imagine if instead of 12 out of 100 of those tests failing because of downstream dependencies, imagine if it was thousands. You'd stop looking at tests at that point. You'd say, well, I've spent an hour looking at the test and it wasn't even my problem. It was some other service that failed. That's not good. What we needed was some sort of foolish engineer to take on a project like this. Hi, that's me, foolish engineer. They said, Jem, we have this hard problem. Do you think you can solve it for us? I'm like, yeah, of course I can. See, little did I know that 4 or 5 engineers before me had tried to solve this and they couldn't. Nobody told me that. Nobody said, yeah, Jem, actually, we've been trying to solve this for years and we couldn't do it. No, it wouldn't matter. I'd still go into it. So I went into it thinking, how can I tame this complexity? What would you do? I probably did the same thing as you. I started with mocking. Mocking is this idea that you take an API endpoint and you say, hey, I know what it's going to return, this basic structure. How about I just mock all of that out? And then I just keep that statically and it'll work. It's a good idea. Doesn't work. What happens when many of those downstream services change, which they do all the time? They change every single day. Well, now I have thousands of these JSON payloads that are now out of date, so I need to keep them back up to date. Because remember, I'm not the only engineer here. There's a lot of engineers and they're constantly pushing all the time. They're pushing code. We're trying to make it better all the time. And sometimes things break. Remember what we said about code and bugs? It's true here too. It's true everywhere. So mocking wasn't going to work. What do we do now? Sorry, I lost you here. There we go. So mocking won't work. How about record replay? Record replay is this idea where we take this. Whoops, sorry, I am getting a message and I don't know what it says until I switch out. Apologies for this.
It's about time.
Okay, I will speed through this then.
Thank you.
All right, so record replay is the idea of recording an API request and playing it back over time. That wasn't going to work because there are things in every API request that change, like a timestamp. And not every single API request, even though it looks identical, is going to return the same thing. So record replay wasn't going to work. So what do? I went like I do. I talked to my manager, Mr. Ryan Burgess. I said, Ryan, I'm stuck. I can't solve this problem. And Ryan said, it's okay because we don't hire you to write code. We hire you to solve problems. And if you can't solve this problem, that's okay because you learned something. So I kept pushing. I pushed myself to the edge. You know, the edge where you can only think about this problem. That's all you can think about. You're on a date. That's all you can think about this problem. That's where I was. I was up late at night trying to solve this problem. And eventually I came upon it because I knew that Ryan and my team believed in me. I took this API, I cut out the things that changed. I split that into a key. Then I had the test name, the method, the request count, and the SHA-1 hash. And that brought our testability from 88% to 99%. Problem solved. And not only that, it was 33% faster. All the tests run 33% faster, serving us millions of dollars in server costs. That's Atticus. That's my project. That's hours and hours of work to try to solve this hard problem. Because what we can take away from all these is it's the code we don't write. It's having freedom to explore. And it's this idea that we believe in people, not ideas. And that's what engineering performance is. And that's how things work. What happens if you empower your entire team? What can you build then? Thank you.
Thank you, Jem. Thank you for that fantastic presentation. Any questions? Okay, we entertain only one question because our time is fast spent. Any question? All right, one question.
Hello, Jem.
Hi.
Are you okay if I call you Kratos?
Sure. I mean, maybe I'd rather be like Thanos or something, but you know, Kratos works too.
Good. I like your beers though. A bit lesser than mine. Yeah, my question is this. Is it possible, to have a very great UI without sacrificing performance?
Oh, absolutely. The thing is, it takes discipline. Don't let anybody say any one library is going to solve your problem, or if you use functional programming, or if you use this, or use that. That's not going to solve your problem. The way to build great UI is to think about it as you're building this thing that's going to run on tons of devices, low end and high end. I can build great UI that doesn't sacrifice performance. There's a cost to that. It's going to take a bit more time to build. So what you really need to balance is that performance versus the quality of the UI. And somewhere in the middle is where we put good software engineers.
All right, thank you. Thank you, Jem. Thank you for the presentation. Thank you for waking up so early.
Thank you for listening. Wait. Can I do this one thing? Can you see me? Wait, I'm going down the stairs.
All right.
Okay, I'm done. Thank you, everyone.
All right, so that was a very interesting session. How things work. Yeah, the code we don't write. That's very deep, actually very deep. The code we don't write. Reminds me of the server problems. When you have performance issues, you either what? How do you do, for the DevOps guys there, or the guys that work on performance, you either do like the horizontal scaling or the vertical scaling. Some you throw more servers to it, right? If there's a problem, a performance problem, you just throw more servers to it. And the same thing to do with engineering problems. If there is a problem, you throw what? More engineers. Add more engineers to the team. It's time for you to build a clone of Facebook, right? And you've been given, what? A time of what? 5 months? And you have 3 engineers. When it's in the 4th month, what happens? Throw 7 more engineers so that it can finish before the 5th month. Nah. The code we don't write. Feels like a prayer session. Anyways, so So our next speaker, this session is going to be very interesting. So this session is about web fonts. Web fonts. How many of us take web fonts very seriously? You know there's actually a loading strategy for web fonts. Programming is very deep. I'm telling you. When you start out coding, you learn HTML, you learn CSS, you learn JavaScript, and then the more you mature as you code, the more you discover you don't know anything, right? Because you start focusing on different parts: accessibility, performance, web fonts, just the UI, back end. Then when you focus on UI, some people will just focus on a particular part of the UI, and they start seeing very interesting problems. Yeah. So the speaker that is going to speak to us right now is a web font expert. I'm not going to say too much. Huh? Hey, Zach, can you hear us? It's not around. So his name is Zach Lederman, and he's a web developer with the award-winning Filament Group. Now, it's funny because if you search for Zach on Google, he has actually done a lot of stuff about web fonts. So he's a web font legend. And then the title of his session is Web Fonts Are Rocket Science. Hey, hello. Zach.
Hey.
Can you hear us?
How's it going, everyone?
We're just talking about your legendary status.
Oh my goodness. Please don't. Yeah, I spent a lot of time studying web fonts, so hopefully the next 25 minutes will be as informative as I hope it can be.
All right.
All right, we ready to get started?
Yes, let's get started. You can take it away now.
All right, great. So as was mentioned, my name is Zach Leatherman. I am Twitter, ZachLead.com. You can read all my blog posts about web fonts. I have an entire section on there. So if anything seems confusing, you can go back and review some of that later, and I'll plug some more on that. So today we want to talk about web fonts, right? So web fonts are rocket science. The claim I'd like to try and convince you of today is that web fonts are actually not rocket science. It's much easier than maybe you might have previously thought. I got 4 sections to this presentation. We're going to talk a little bit about U.S. politician Mitt Romney. Sorry. We're going to talk a little bit about invisible and unstyled text, so the behavior while web fonts are loading, some font face block syntax, and then we'll go through some strategies at the end to make your fonts appear to load faster, quicker, render faster. So this guy, I don't know if anyone recognizes this guy, probably not. He is a U.S. politician. His name's Mitt Romney, and in January of 2015, so I guess 3 years ago now, he was trying to decide whether or not he was going to run for the U.S. president, So he was kind of going back and forth, couldn't really decide. And so eventually he did make a decision, and he announced it. And then Slate.com ran this article on their website, and it said, the headline read, Mitt Romney is officially running for president. And James Muspratt got a little screenshot of this, put it on his Twitter account. But the problem is that this isn't the decision that Mitt Romney had actually made. What happened was that Mitt Romney was not running for president. So this is what the website looked after all of the web fonts had finished loading. So while the web fonts were loading, a completely different message was communicated to the users that were viewing the website. So it's a huge problem for web fonts, especially for news companies, news organizations that really want very accurate content. They don't want inaccurate information to be communicated through their websites. So, and I'll go through a little bit more about why that happened later. But first, before we dive in, I want to talk a little bit about rocket science. It's aerospace engineering. It's really divided into 2 separate groups, aeronautical and astronautical. Aeronautical is things that fly in the air. Astronautical is things that fly in space. But actually, this is completely irrelevant. We don't need to discuss this too much because, again, the premise I'm trying to communicate right now is that web fonts are not rocket science. They're 2 completely separate things. Okay, so the next section I want to go through is just invisible and unstyled text. So what happens while a web font's loading? So web browsers have kind of chosen a default way to render the text while the web font's loading. The default behavior that a lot of web browsers use today is to make the web font invisible. The text that's using the web font is invisible while it's loading. Then when the web font finishes loading, it will re-render using the new web font content. And this is known as the flash of invisible text, so a FOIT. And this is kind of problematic, right? Because, and I love this tweet from Anand. He says that, remember when the text used to load before the images did on websites? It seems kind of crazy that the new web font behavior has kind of pushed text, the actual content that many people want to read on the website, to the end of the waterfall. So I think it's very important to sort of mitigate these problems. So one thing that web browsers have tried to do, another approach that some web browsers have taken, is to use something called the flash of unstyled text. So this will render your fallback font while the web font is loading. So this might be your normal sans serif rendering here, and then when the web font comes back, when it loads successfully, then it will re-render using your web font content. So it uses fallback system fonts while it's loading. And this is known as the flash of unstyled text, or FOUT. And this is kind of an oversimplification, but these two different strategies have kind of pit designers and developers against one another. For the most part, designers want to display a finished product. They want to exhibit control over their medium. And developers want to render a minimum viable product to the user as fast as possible. So how do we find a nice middle ground where we can make both parties happy? And it isn't a solved problem. There's not really a consensus right now. It's still very contentious. And you can kind of see that throughout the history of different font face implementations in web browsers. So back in 1997, the first web browser to implement web fonts was Internet Explorer. Hooray, Internet Explorer 4, nice job. And they actually used a full flash of unstyled text. So they rendered a system font by default to the users while web fonts were loading. And then a couple of browsers came along, and the next browser to implement font face was actually Safari in 2008. They went full flash of invisible text. So all the web font text is invisible while the web font's loading. And Chrome joined, Firefox joined. Firefox actually switched from flash of unstyled text to flash of invisible text. But they added something a little bit different. They added a 3-second timeout. So if the web font took longer than 3 seconds to load, they would render the system or fallback font. They would switch to FOUT, the flash of unstyled text, until the web font had successfully loaded. And this is kind of a compromise that they introduced. And this is great, right? Because this created, this made it so web fonts were not sort of a failure, a single point of failure for your content. If the web font, the request hung, you may never see text if you don't have this fallback or this timeout. So Opera joined them, they switched, everyone is moving all around. And then a lot of browsers really kind of settled on this 3-second timeout. So it's kind of a compromise. But really the problem is that 3 seconds is quite a long time. It's quite a long time for invisible text. So let's just kind of sit here together and endure 3 seconds of waiting. And that's a long time to wait when your web font or when your web page is loading, because a lot of users might give up by the time 3 seconds of invisibility have taken place. And if you want to kind of play around with this yourself, I built a little flash of invisible text, flash of unstyled text comparison. You can check it out. Go to this website. I'll put these slides up later today. And you can kind of play around and it'll show side by side the difference between flash of invisible text and flash of unstyled text. So you can kind of get a feel for the different performance benefits of each. All right, let's talk about a little bit about lift coefficients. How many of you guys know about lift coefficients? They're great. Dimensionless units relates to lift generated by a body compared to the fluid density around the body, the fluid velocity and associated reference area. I'm sure you guys are all familiar with this this formula here that's on the screen, but we don't have to worry about any of that, because web fonts are not rocket science. All right, let's talk a little bit about font face syntax. So first thing you got to do when you have a web font is you might go out to find some syntax that exists already on the web. There's this bulletproof font face syntax that was really popular for quite a long time. And the thing what we want to do is just burn it to the ground because we don't want to use any of this. Well, that's not true. We'll actually use a little bit of it, but we can actually simplify this quite a bit nowadays. So we want to retire this bulletproof font face syntax. We want to move forward from the thinking that content fonts need to be served in all web browsers, because really web fonts can be a progressive enhancement when you're dealing with content fonts. Now, icon fonts are a completely separate thing. We can go into, I could do another 40 minutes about the difficulties with implementing font loading and icon fonts. We're not going to do that today. I would recommend that if you want to use icons on your site, to go with SVG, so you don't have to deal with all of these web font loading considerations with a completely different mechanism. So you just use SVG, and then you won't have to worry about a lot of these font loading problems that come with icon fonts. So the font face block that we can use nowadays is just two file formats, the WAF2 and the WAF format. And it's much simpler, much easier. And web browser support is actually really good for this format stack. Use WAF2 because the compression, so in both WAF and WAF2, the compression is built right into the file format. You don't need to worry about any server configuration or compression headers to set. It's all built into the files, so you can just go ahead and use them. And in some cases, you might be able to get away with just using WAF2. You need to look at your the browser support that you want to deliver for your site, but WAF2 support is really pretty good right now. For my stuff, I still use WAF and WAF2. All right, so we talked a little bit about font face syntax. Let's talk about strategies that we can use to make our web fonts load faster. So let's go back to our buddy Mitt here, our Mitt Romney problem, the Mitt Romney web font problem. I love calling it that, so we can blame him for that problem. So yeah, he had two web fonts. The site was two web fonts on the site, title in Gothic and a title in Gothic italic. And so you might be able to guess what happened here. Each web font has its own independent loading lifecycle. So each web font has its own 3-second timeout, its own flash of invisible text, its own flash of unstyled text. So in this case, the normal or Roman style, the non-italic style loaded first. And the italic web font was still loading. It was still flash of invisible text here. So nothing was showing when it wanted to render that knot to the screen. So the easiest thing we can do to fix this is to add, there's this great new CSS descriptor that we can add to our font face block. It's called font display. And if you use the swap value there, it will basically emulate, or it will basically force the web browser to use a flash of unstyled text for everything. So that's kind of it. So congratulations, we did our first font loading strategy. Yay. I can't hear if anyone's cheering, so I'm assuming the crowd's going wild with this one simple, tiny little font display descriptor. And the browser support is actually pretty good for it. It's in Chrome, it's in Firefox, it's in Safari. Not quite in Edge yet, but I assume it's coming soon. And the great thing about this is that it eliminates all the race conditions that we had for this problem, the Mitt Romney web font loading problem. So if we look at both mechanisms, so each individual path that our web fonts can take, on the left, you can see the behavior that happens when the regular font is loaded first. So our regular font renders. The web font is showing in green there with the green check mark. And then the fallback font renders in the italic. So it doesn't matter which font will load first, you'll always have readable text, and you won't have incorrect, inaccurate headlines presented to your users. So that's great. That solves our race conditions there. We don't need to worry about which web font's going to load first, but your web fonts might still appear to be slow because the fonts are still loading at the same time. You've just made them visible while they're loading. You've changed the perceived performance of the page. You made the text instantly readable, but it didn't actually make the web font rendering happen any faster. So to learn about why this happens, or to learn about things that we can do here, we need to know what checklist, what criteria must a web browser meet before it actually starts to download a web font. So first, it's got to parse your CSS. It's got to find your font face blocks, but it also has to find nodes in the document that use your font family that matches in your font face block, that are not empty. They have to have text content in almost all cases. And if you're using a Unicode range on your font face block, that needs to match with your text content as well. And the reason browsers do this is a performance optimization, right? So my favorite example of this is New York Times at one point had 191 font face blocks in their CSS. They just dumped a ton of web fonts on their website. And I went back and checked last night, and they're down to 110. Congratulations. The trend is improving. But it's because web browsers have chosen to sort of use this performance optimization, it's not a huge deal because web browsers only load web fonts that are used in content on the page. So it's not the end of the world that this happened, but it's definitely a performance optimization that they could improve. And I guess they are improving slowly. So the problem here, so web browsers have sort of worked around this problem with sites dumping a bunch of font face blocks on their page. But the problem is the browser doesn't know to download fonts until super late in the waterfall. Web font requests often don't start until right before your website's about to render, which is not great. It's really bad. That's why you see a lot of invisible text if you're browsing around on a slow connection. So the one thing that we can do to work around this is to use preload. So preload is a hint to the browser to tell it to download it higher in the waterfall. To download it, it tells the browser we're going to use this resource later on, and you should download it ahead of time. And to do this, it's really just a simple link element you can add to your head. Preload, and you can preload a bunch of different kinds of things. You can use CSS, images, JavaScript. In this case, I want to preload my WAF2 format. And you want to use WAF2 here because all browsers that support preload also support WAF2. But really, this will cause your web fonts to be downloaded quicker, higher up in the waterfall, and it'll work a little bit better. Your web fonts will render sooner. So we kind of went through two different things that you could do: font display and preload. Those are very easy things, a CSS thing and an HTML thing. But let's do a little bit more. Let's go a little bit further. So there's another strategy I want to talk about today, and this is the Fout with a class strategy. And this uses a little bit of JavaScript. So in this example, let's just assume that we have two font face blocks, normal Lato, and then a bold Lato. And using something that's known as the CSS font loading API, we can use code to sort of hide our Lato usage in our CSS behind this fonts loaded class, behind the fonts loaded class. So we only use the Lato font family inside of this sort of guarded fonts loaded class on top. And then we use the CSS font loading API below to add that class to our document when our fonts have successfully loaded. So we programmatically trigger, using JavaScript, using the CSS font loading API, the load of our two web fonts, document.fonts.load. And then when those have loaded successfully, that's when we render those to the user using this fonts loaded class. So we trigger that usage of Lato on when the fonts have successfully loaded. And the browser support for this is pretty good. Not in Edge yet, but hopefully it'll be coming soon. If you want in Edge right now, you can use polyfill. You call it Font Face Observer. There's the URL for that. And again, I'll put these slides online so you don't need to write this down. We'll have access to these resources later. But the great thing about this approach is that there's no flash of invisible text, which, all right, fine. We can get that from font display. So that's not a great new thing. But it works with third-party hosts. So Google Fonts, for example, notoriously doesn't work with font display, but this font with a class approach will. But really the big one is that you can group repaints together. So if you're using multiple web fonts from the same font family, you can group those repaints so they all render at the same time. And that's huge, because you don't want, if you're using 3 or 4 or 5 web fonts on your page, you don't want every single web font render to sort of cause your page to jump around. Yeah, so that's kind of a little bit janky there. So we can work around that using grouped repaints. And sort of the downfall of this approach is that you don't want to use your Lato font family outside of that guarded class. It'd be very bad to just dump Lato inside of a body block there, for example, because that would trigger a load of Lato earlier than you want to. So you have to manage all of your font family use very meticulously. Well, sort of. So there's a plugin you can use, Post CSS FOF classes. You can use this to process your CSS for you automatically. And I wrote this and I based it on a plugin that Netlify put out. Very great Post CSS plugin. And it will process your CSS for you automatically. So you can just use your web fonts in your CSS as you normally would, and it will transform those for you with whatever fonts loaded. If you want to change that, you can change that. But it will hide your font family usage behind that guarded class for you. So yeah, it works great. So let's go back to some rocket science, right? Has anyone heard of the Big Dumb Booster? Amazing, awesome, great. Big Dumb Booster. It's actually an aerospace engineering principle that I think might actually be kind of applicable to how websites are built today. And it states that a bigger, dumber, and simpler rocket is often cheaper to build and operate than a smaller, more efficient, and more complex rocket. And I kind of like that, but again, it's irrelevant because web fonts are not rocket science. Okay, I want to go through a couple of things real quick here at the end. I want to talk about font subsetting. So we talked about how to make our fonts load quicker, higher up in the waterfall, how to render them while they're loading. But really another great thing you can do is to reduce the number of glyphs that are inside your web fonts. Make your web fonts smaller. So we talked about compression, WAF, and WAF2 formats. Those can make web fonts smaller. But the other thing you can do is to just remove things from the web font content or from your font files. Assuming that your internationalization and language and licensing requirements allow it. Some fonts don't allow you to subset, so you need to make sure that your license works with that. And so I have a tool to do this called Glyphhanger. You can check it out. It's on the Filament Group GitHub. It's actually pretty easy to use if you are familiar with the command line. The standard thing that it does, it will go out to a website, find all the characters, the Unicode range that's used on that website, and it will spit it out to you. So I'm just running this against my website, and here's the Unicode range for all the characters I use on my website on this homepage. And you can also output the string as well. This is what it renders like in the console. But the nice thing about Glyphhanger is that you can also automatically subset web fonts here too. So you just feed it a glob of files here for your web fonts using this -- subset, and it will automatically transform these files and convert them to WAF, WAF2 formats that you can use right in your pages. And it's really a huge amount of savings too. So this example that I ran is my website, reduced the number of glyphs by a lot, but really with this compression, with all 8 variations of this font, it went from 1.14 megabyte down to 93 kilobyte after using WAF2 compression. So it's a huge amount of savings. So it's a big deal. And you could pass your own whitelist in too if you want to subset without using any sort of spidering content. You can just pass your own strings or Unicode range right into it. So it's a great, easy way to subset web fonts. And this is great because smaller font files load faster. We want to reduce our Flash invisible text. That will reduce your Flash at one style text. We want to get our web fonts rendered to the user as quick as possible. And so the last thing I want to talk about before we do questions is variable fonts. So variable fonts is the great new, it's the new hotness in web fonts. It's amazing. Everyone's excited about it. I'm super excited about it. Variable fonts are awesome, and I'll tell you why. So before, you might have had 8 different variations, 8 different styles of a web font loading on a page. So in this example, San Francisco, we have 8 different weights loading here. The great thing about variable fonts is that we can combine all of those weights into one single variable font file. And then it uses math to sort of interpolate the different weights for you automatically. So you only need to load one thing, and you get all of the, like a huge number of weights built in. A great resource for playing around with this is called Access Praxis. You can check access-praxis.org for this. And you can see the little slider going back and forth. It gives you a ton of different font weight variations that you can use here. But the really amazing thing about variable fonts is that you can have any number of axes built into a variable font. And font authors can sort of customize those. So it gives us it gives web authors a ton of power to sort of render web fonts how we might want them to be rendered, and truer to how the author might want them to be rendered too. And browser support for this is actually really pretty good. Firefox behind a flag, it's kind of lagging behind here, but it's coming, and it is available in Edge right now, so it's great. The only downside here with variable fonts is that you're paying for this extra math with kilobytes of content. So just as a simple example, we have Source Sans Pro with 3 different variations here, Roman, Light, and Bold. That weighs about 116 kilobytes, and WAF 2 when you add them together. And the variable font is about the same size. So if you're only using a single font weight or a single axis on your website and your rendering, you really might not get a great benefit out of using a variable font. But if you're using 3 or 4 or 5 different variations of a web font, that's when you're going to get a real great benefit from using a variable font. But the thing I'm super excited about, the thing that's really great about variable fonts, I think, is that they force grouped repaints. All your web fonts are going to render at the same time. So we don't need to do sort of this more complex JavaScript stuff built in. It's built in right into the font format. So using variable fonts, using font display, using preload, a lot of these race conditions that came with Mitt Romney's web font loading problem go away. All right, so I guess it's the end of the presentation. I don't know if I don't know if I've convinced you that web fonts are rocket science or not. Hopefully you are maybe closer to thinking that they aren't than when we started. I do have just a checklist at the end that I want to go through super quick. This is just the things that we want to think about when we're font loading. We don't want invisible text. We want unstyled text. We want to reflow as little as possible and as soon as possible. We want fewer repaints. We want to group them. We want to trigger our downloads sooner. We want to make our font files smaller. And these are the things that we can do to achieve that. Font display, CSS font loading API, variable fonts, preload, a WAF 2 compression, and subsetting. Really, really great tools at our disposal. And we're really at this great point right now because a lot of these approaches are not JavaScript, or without JavaScript. You don't have to use JavaScript to use them. So if you want to read more information, I have a comprehensive guide to font loading strategies on my website. It's a giant blog post. There's another version of that coming out later this year. And then I have a bunch of demos on this GitHub repo, web font loading recipes, so you can check out actual demo code. All right, so just a quick thank you to all the people I look up to and the people that have helped me develop this presentation. Follow them on Twitter, and thank you.
Thank you, Zach. Thank you for that informative session.
Yeah, you're welcome.
Okay, so because there is no time, so there won't be time for questions. But then if you have questions, you can hit him up on Twitter at
yes, absolutely.
Zachlet. All right. Okay.
Yeah.
Thank you very much, Zach. Thank you.
Thank you.
Bye.
Thanks, everyone.
All right. So That session was very packed, a lot of information. Man, web fonts are not rocket science. I hope you guys are convinced right now. It's crazy. Okay. So actually, the next speaker is going to be talking about designing progressive web apps. And I'm sure we're very familiar with progressive web apps, right? Yeah, I know progressive web apps has been a thing for how many years now? 3 years, 2-3 years. And the amazing thing about progressive web apps is that you are trying to make your web app look like a mobile app. So like your mobile web app is looking like a mobile app, right? And then you can decide to build an app that works offline. And when the user gets is connected to the internet, it can sync back to the server. You can actually add your app to the home screen, you know, so you can just launch it from the home screen instead of having to go to your URL on your browser and go to the and put in the URL every time. You can just launch it like an app. So Jason will be talking about designing progressive web apps because there are a lot of things involved. And you know, earlier we had a session that talked about service workers. So service workers too is like the backbone of progressive web apps. So is Jason around? Not yet. Okay. Are we tired? Are we tired? I can see angry faces already. It's 3:42. You know, if you're at the office, you still be at the office. How many of you work remotely here? I mean, apart from the guys that work remotely, just be chilling at home now or something. But I don't know. Do we? I know the remote culture is becoming a thing in Nigeria, but the trust is not there yet. Is it? Yeah. So when you tell your employer, I can actually work remotely, say, you know what, work from here first. For the next 5 months, we assess you. After 5 months, when you bring up the topic again, it's like, let me talk to the investors. Let me talk to the stakeholders. If they agree, then we can work. And I remember, I think I tweeted something about, I know they were talking about like fixing the Third Mainland Bridge, right? And then I was talking about, you know, people deciding to work remotely. Okay, Jason is around. Hey, Jason.
Hello. Can you hear me?
Yeah, we can hear you.
Excellent. Excellent.
Are you ready?
Sure. Yeah.
All right.
I will start.
You can start now.
Here.
All right.
Sorry. Just 1 second. Okay, are you seeing my slides? Yeah. Can people hear me? See me? Are the slides up?
Yeah, we can see your slides.
Yay! Okay. Well, thank you all. I particularly want to thank the organizers for putting this on, and I am truly honored to be here. This is something I've been looking forward to for quite some time. So I'm going to talk today about designing progressive web apps, sort of following on a little bit about actually what the previous speaker was talking about and what Colin talked about earlier when it comes to progressive web apps, but looking at it specifically from the sorts of questions that a web team might face as they start doing this. We've had a couple of our clients where the president or the CEO of the organization comes to the web team and basically declares that they need a progressive web app. And oftentimes the team itself isn't as familiar with progressive web app, or at least not all of the members on the team. The developers might be familiar, but oftentimes the designers, the product owners, the business owners aren't as familiar. So I want to talk about the sorts of questions that that team will face as they start to build a progressive web app. And probably the most pressing one is simply like, how does the CEO even know about progressive web apps? And the CEO does know about that sort of stuff because the press that they read have been talking quite a bit about progressive web apps. Everything from Total Retail and Digiday from an advertising perspective to CMO, like marketing magazines, like the press that executives read are talking about these things. And they're talking about them because of the fact that organizations like Conga are talking about how much less data is downloaded for each transaction. Companies are sharing their success. Pinterest has written about how they've seen increases in user-generated ad revenue, ad click-through rates, user engagement. They have written about, just recently, a couple weeks ago, they did a follow-up post talking about how they've had their progressive web app for a year now. And it used to be that mobile web was the least likely way that somebody would find or sign up for Pinterest. And now it is the most likely way. We hear so many of these stories that we created a website called pwastats.com that allows people to keep track of, or where we keep track of case studies where people publish about progressive web apps. The other question that organizations bump into, and probably there are people in the room who have done progressive web apps, maybe some folks who haven't done this. I don't want to go into great detail on this, but we do run into situations where people don't know what a progressive web app is. And even people who have built progressive web apps have written about how confusing it is. And the reason it's confusing is because when Francis Berryman and Alex Russell came up with the definition for a progressive web app, they observed some behavior they were seeing out in the world related to websites that were doing things that previously hadn't been done. And they created this definition list, these 10 things. Progressive web apps are responsive, they're connectivity independent, so they're resilient to networks. They have app-like interactions, they're safe, they're fresh, they're discoverable, meaning they can be installed, they declare themselves as an app, they're re-engageable, they're linkable, and progressive. And those last two, I think, are the really important pieces because there have been a lot of attempts to do this sort of stuff with the web before, like Adobe Air, that weren't really part of the web. But despite this sort of clear definition, Google on their site, when they first started talking about progressive web apps, wrote about how there were 6 definitions, or they had this first 10, and then they narrowed it to 6 things that didn't quite match. And right now, if you go to their site, they talk about fast, reliable, and engaging. They recently added integrated so that they could have this definition that's FIRE. It's fast, integrated, reliable, and engaging. But that really doesn't tell us much of anything. Like Craigslist might qualify as fast, integrated, reliable, and engaging. So thankfully, Jeremy, who I believe is speaking tomorrow to you all, he had written about how a progressive web app is simply a website that's enhanced with HTTPS, a service worker, and a manifest file. And this is actually the definition that I had intuitively been using when I tried to make decisions about whether to include something in PWA stats or not. So I find this definition to be really helpful. The key here is the service worker, which I know Colin talked at length about earlier, and how it creates things that are more performant. And I tend to think of progressive web apps as a Trojan horse for performance. The performance related aspects of it, I think, are where the big wins come in for users. But progressive web apps allow us to build experiences that previously required native applications. And the sort of ambiguous sort of buzz hype around progressive web apps allow organizations to revisit the web in a way that they may not have revisited in a while, and to think about what's possible there. And to realize that over the last decade that browser makers have spent a lot of time making browsers better, making them more feature rich. And so it's possible to do things that we weren't able to do before. I keep reading articles talking about how you can't use the camera on the web, or you know, like which Instagram has a progressive web app, so that's not true. Or you can't use your fingerprint sensor. And I'm writing a book on progressive web apps, and I was trying to take a screenshot of the payment request API on my phone and accidentally bought a pair of socks. Because to take a screenshot, you actually use the same buttons for taking a screenshot as you do like actually purchasing something on an iOS device. So I think that the web can do much more than we commonly think it can. So the team may get together and say, okay, let's do this. Let's go build a progressive web app. And when we start thinking about design, not from a like how do things look perspective, but a what is the strategy, what are the capital D design decisions that we're going to make, I think that we can really look at progressive web apps in 5 different sort of factors. Making it feel like an app. How do we make sure that people can install it and discover it? What do we do with offline mode? What do we do with push notifications? And then what do we do with the things that aren't technically part of a progressive web app, like the payment request API, accelerated mobile pages, AMP pages, or credential management API, those sorts of things that aren't technically part of progressive web apps, but are things that people commonly think about when they're looking at doing a progressive web app. I'm not going to have time to go into number 5. I'm just going to look at sort of the first 4. So when it comes to making something feel like an app, this is probably the most difficult one to sort out, because people don't have common definitions of what it means for something to be a web app versus a website. Chris Coyer on CSS Tricks a couple of years ago did this quiz or this survey where he asked people, you know, is it important to distinguish? And 72% said that yes, they're different things with different concerns. But if you read the comments on that post, nobody agrees. Nobody agrees what makes something a web app versus a website. Jeremy Keith said that like obscenity and brunch, web apps can be described but not defined. And so as you and your colleagues start talking about building a progressive web app, I can guarantee you the fact that it's an app is going to seem like it's something important. The fact that, but what that means is probably going to be different for each person in the room. Often what we think of when we talk about making something feel like an app is making it look native. And this goal can be challenging. We can accomplish some of this. We can, for example, change the fonts to replicate the system fonts for a particular operating system. But how many platforms will you adapt to, right? Like we don't currently adapt our websites on desktop to look like Mac or Windows. And then when the platform changes that design language, like Microsoft did a couple of years ago when they moved to Fluent design, do you change your app accordingly? Or when iOS changes from sort of the skeuomorphic design to the flat design of iOS 7, do you change? Does your whole entire web application need to change then? I think that we're better off defining our own design and being consistent. This is Tripcase. It's a travel application. It's a phone gap application that feels great whether you're on Android or on iOS. In interest of full disclosure, we did a bit of work on this app, but we didn't design it. What I really appreciate about the app is that they just created what they thought would be the best mobile experience, and they made sure that it didn't stand out on any particular platform, and it works really, really well. Another way in which people want to have something that feels like an app is to have a more immersive experience. And with the manifest file in a progressive web app, we can declare different display modes. Everything from browser, which still has all of the Chrome, to minimal UI, a little bit smaller Chrome, standalone, where we lose the address bar, and then full screen. And with full screen, we've got that full immersive experience. But I think in a lot of ways, we're spoiled by our browsers. We don't realize all of the things that browsers provide for us. Everything from the status bar and the address bar where the URLs are that we use for sharing, to navigation like back buttons. And then inside menus even, things like find in page, downloading, and then the ability to print and to email. And so when you move to full screen, you have to add these things back. Even something like adding the back button is harder than it seems. First off, if you've got a traditional web application where you haven't had to manage the back button history or the browser history, all of a sudden that becomes something you have to concern yourself with. And a back button in an app often implies a hierarchy. For example, in that little short video there, somebody goes from the Polymer Shop homepage to a product category page to a product, and then up to the category page, and then down to the product. And you have this sort of pogo sticking back and forth behavior. But the web's not that way. The web isn't linear in that fashion. As a matter of fact, you could go to a search result and go directly to a product page. And then, and this is exactly what you would see. You would have a back button in the page and a back button in the browser Chrome, but they don't go to the same location. Even though they look very similar, the back button for the browser goes back to the search results, whereas the back button in the page would go up to the product category page and sort of go into that app hierarchy. We have a way to make decisions about this. There's a new display mode media query that allows us to know what mode we are in, and maybe we only display the back button if we're in full screen, or maybe full screen and standalone. We have to sort of adapt to this new idea that like when we adapted to responsive design, where we were designing for a continuum of screen sizes, we have to design for a continuum of contexts, because not every person is going to actually install the progressive web app to their home screen. The majority of people will probably interact with it inside of browser Chrome. But because service workers and push notifications on all those things work, even if somebody doesn't have it on their home screen, everybody's going to visit, everybody like kind of will install your progressive web app, even if they never have the icon. I think we get a little too fixated on the icon part. Another way that people want to make something feel like an app is to have fast and fluid experiences. So we can do that, and native apps do this all the time, but from a web perspective, we can do it with service workers, because we can use skeleton pages to have placeholders for images and other assets, so that before a page loads, we've already set aside all the space so the page doesn't jump as somebody scrolls. There are a few things more irritating than, as you're reading an article, having the thing that you're reading move as you're trying to read. Another thing that Google spends a lot of time talking about is this app shell model of progressive web apps, where the app shell is the header, the footer, the menu, the things that are sort of containing the content. And with a service worker, we could store all that stuff in the cache explicitly, and then only go get the new content. In many ways, this is what native apps do, right? They download a binary that contains all of that shell, and then they just go get new content. And doing this means that you've got a much faster experience, because perceived performance matters more than actual performance. And so the fact that that stuff is available offline means that the shell can be put on the screen really quickly. But for a lot of organizations, app shell also means a big investment in re-architecting their site. It probably means moving from a traditional web architecture with a series of page requests to something that is a single page application. or using some of the newer technologies like streams to possibly replicate something like a single page application. So I think it's important to note that progressive web apps do not necessarily mean that you're doing a single page application. Our website is a progressive web app. It's really fast. We designed the site to be fast. It was fast before we made it into a progressive web app. Once we had done so, it was so fast that it didn't seem like there was going to be a big benefit to making it into a single page application. And it was built on WordPress because we really like being able to have content and articles that people can comment on and interact with. And so like we just decided that this wasn't a necessary part of what we needed to do. The last bit is that feeling like an app shouldn't be a goal unto itself. People who, whether your progressive web app is more of an app or site, like isn't something that users are going to be thinking about as they interact with it. They're just going to want an exceptional experience. And so now when we think about feeling like an app, we have this sort of continuum from basically having something that is a website that's using progressive web app technology for performance and improvements to something that's full screen, app shell, using native design language. And we've got really less complex versions and more complex versions of something when it comes to a progressive web app. All right, the second factor is installation and discovery. So manifest files are simple JSON documents where we declare stuff about a progressive web app, like the name and icons and things of that nature. And we can do a little bit with this to actually provide a better experience. So we can declare what the startup screen's background color should be. But as you'll note here, since they look different, you should really test that because each browser handles it differently. We can also set theme colors. So even if somebody never actually installs a progressive web app, they can have an experience that feels more custom. Lyft does a really good job of this, where their theme color actually makes the whole thing feel like an app even before you install it, because the browser Chrome just sort of blends in with their overall design. Once you've got a manifest and you've got a progressive web app, browsers will start prompting people to install your progressive web app. So in Firefox and in Samsung, they have add to home screen badges. So in Firefox, it goes from, they add a little icon with a home and a plus button. On Samsung, it switches from being a star to a plus, and then once you select it, it opens up and has the add to home screen option. These are very subtle. So Firefox actually provides people with something that says, hey, look at this, like this is a new icon, this is how it works. Chrome and Opera are doing something a little more invasive. So they have banners that pop up on the screen that say add to home screen. They catch more of the user's attention. But because they're more invasive, they have heuristics where users have to interact with the site, interact with the progressive web app for a certain amount of time before they will actually get those prompts. Flipkart, an e-commerce company in India, has done something I think is sort of a best practice in this regard. They wait till the browser says, hey, this user's passed in user engagement threshold. And they basically say, thank you for that. And they just hold on to it. And then they wait until the order confirmation page when, and they think that somebody will be more likely to install it. And then they prompt for the add to home screen. And by doing so, they see a 3x increase in conversion. And this is a best practice now, but it's pretty much going to be the only way we can do this stuff in the future if we want to have this sort of larger add to home screen. Chrome has already announced that they are moving to a mini info bar, and then eventually moving to the sorts of badging that we saw in Firefox and Samsung. And so if you want to have a larger prompt, you have to wait until the user has passed that engagement level, and then you have to, as a developer, declare the prompt yourself. So again, we have this continuum between a less complex version where maybe you don't care if people add it to your home screen, to like really complex things where you might use PhoneGap and trusted web activities to actually put progressive web apps inside native app stores. We also, for offline mode, we can do simple things like caching for performance and having an offline fallback. Even our offline fallback pages can be more interesting. So Trivago has a maze on their offline fallback page that they found that people will return to more once they hit that page. If we're going to do stuff offline, we should let users choose what they want offline. So it becomes really important to communicate what's happening. You can see that as Financial Times actually pre-caches a lot of information, that they let people know what's going on, and they give people control. They give people the option of being able to go in and turn things off. Again, we've got this complex continuum where we have the ability to just cache things for performance to actually having things like probably a really difficult computer science problem of allowing people to edit things in a distributed manner while offline and then sort of reconciling that when they come back online. From a push notification perspective, there are a bunch of hidden challenges. From a front end perspective, it's actually pretty easy to add a subscribe button and connect somebody to a push notification service. But Slack, for example, when they make a decision whether to send a notification or not, they have this complex flowchart because they need to send notifications that are personalized and based on what device somebody's using. We have to be really careful because people are really annoyed with push notifications. So we don't want to ask immediately for permission to send push notifications. Twitter Lite does this really well. They only send push notifications when somebody clicks on the notification tab. Only then do they show the browser prompt. And then they give people a confirmation that then they can use to go and customize their notifications. And this is really important because browsers have implemented kill switches where if somebody doesn't like notifications, they can turn it off and you'll never get to ask them again. Chrome has also made a change where now users can no longer ignore permissions prompts. It used to be that they could either tap elsewhere on the screen or tap the X and just ignore it, and 90% of users did that. But now Chrome is saying you have to make a decision, and they did it so that developers have incentives to be able to continue to go on to the modals, or to make sure that they ask when it's context. So push notifications are also on this sort of continuum. And the last bit I want to talk about is how do we create a plan for something like this? And the way to do so is to roll out incrementally these improvements. That's one of the great things about progressive web apps. And this is what we did with our site, and you can do something similar. The only things you probably need to keep in mind is that you want to make sure that you have, that you sort of think about where you want to be on those continuums. Benchmark things ahead of time to make sure that you can measure stuff. You also will want to assess your current site to make sure that it is fast enough. If your site currently loads on 30 seconds on 3G, it's probably not going to do, like adding a service worker won't cut it. We also have had customers that have websites that aren't usable on mobile devices. But you can build a roadmap where you go from doing some planning and definition to doing technical, sort of like assessing that technical debt, and then build a baseline, do some front end additions, do things that don't require changing the back end infrastructure, and then maybe larger, more complex initiatives. And the great thing is that you can roll out those incremental improvements all along the way and provide value for the people who visit your site. And this is, I think, the really powerful thing about progressive web apps is that each step on the path to a progressive web app makes sense on its own. You just have to start working on them. That's it. Thank you so much. People have questions?
Thank you so much. Jason, are there any questions? Okay. Any questions?
Questions?
Are you sure there are no questions?
All right. Well, thank you all very much. Enjoy the rest of the conference.
All right. Thank you. this space is Aaron.
Yes, it's ready. Let me bring him online.
He's talking about designing the conversation. What's the stuff? Designing the conversation.
Let me check the website.
Check it. Designing conversations or something.
Yeah, designing the conversation.
Designing the conversation. Can you check what's his profile? Okay. He's around.
Yes, come online.
Howdy, howdy.
Hi, Aaron.
Hi. How's it going?
Good. All right. So our next speaker is Aaron. Aaron will be talking about designing the conversation.
Indeed.
Are you ready,
bear with me
Aaron?
One moment here. Get my slides up. Yep. Of course, Keynote decides to disappear on me. There we go. All right.
You see what I'm saying?
All right, take two. There we go. Awesome. Hello, everybody. I'm Aaron, and I'm a web standards and accessibility advocate at Microsoft. And some of you may know me from my work with the Web Standards Project and also with A List Apart and various other publications over the years. So chatbots and digital assistants are all the rage right now, and most of these work from specifically coded data sets and models, but there are more than 4.5 billion pages of content stored online, trapped in many cases within our websites. Articles, stories, blog posts, educational materials, books, and marketing messages are all on the web, but for the most part are an untapped treasure trove of content that could be useful in a non-visual context. There have been a few projects, search engine spiders most notably, that are working on turning that often unstructured mess into something usable. But we can do more, a lot more in fact, to enable our web pages to be more usable both by real people and the computers that power voice-based user experiences. That's what I'm here to talk about. I want to release that content from the screen and empower it to go anywhere and everywhere. I want it to find its way into virtual assistants and other voice response technologies, and even voiceless chatbots, without ever requiring us to code and recode content over and over into multiple redundant formats. I also have a dream of enabling our users to actively engage with our content by filling in forms and manipulating widgets on the web purely via voice. And it's all possible. Ultimately, I'm here to talk to you about how we can use HTML and ARIA to make our content structured, sensible, and more importantly, meaningful. And it all begins with the humble element. So consider this M element up on the screen. We can switch back over to the screen here. Sure, it's visibly rendered as italics, but it also adds emphasis to the content within. HTML is chock full of elements that are useful for conveying meaning, nuance, and relationships. And being aware of these enables us to author more expressive documents. Ignoring them can undermine the usability of the content we're marking up. When we create a web page, we need to be mindful of the conversation that we're creating with our customers, and in the process, choose elements with intent and care. One of the best indicators of how HTML will make it into our virtual assistants is another assistive technology, screen readers. Not only do screen readers do as their name implies, they also allow users to rapidly navigate a page in various ways and provide the means to translate visual design constructs such as proximity, proportion, etc., into audible cues, or at least they do so when documents are authored thoughtfully. So without further ado, let's jump in and look at some more solid examples of how we can create more meaningful documents and empower them to be more usable in a headless UI context. We'll start by looking at what are called phrasing elements. The emphasis you saw earlier is an example of this element type. We used to call them inline elements because, well, by default, they're visibly displayed as inline text. But phrasing is a much more accurate description of the role they play in our web pages because, well, they mark up phrases. We saw this example earlier. Here, the word really is marked up as emphasized. When spoken, it might sound like this: I'm really happy to see you. Sometimes emphasis isn't enough. When we want to indicate content is very important to our customers to pay attention to, the strong element is the right way to go. Strong means of strong importance. Please fill out the form below to contact us. All fields are required. Now, visibly, M and strong are displayed as italics and bold, respectively. Now, in the early days of the web, we also had the I element and the B element that were rendered exactly the same as these two, leading many of us to believe they were actually interchangeable. And with B and I being shorter to write, they proliferated on the web. Semantically, however, these elements are quite different than their doppelgangers. The I element is similar to the emphasis element, but more generic. It's used to indicate an alternate voice or mood. It could be used to indicate sarcasm or idiomatic remarks or shifts in language. It's a terrible movie and it made 200 million. Go figure. Or she's admired for her energy and joie de vivre. In the latter example, you might notice that I also have indicated that the language being shifted to is French. And that's a shift from the natural language of the document of English. This indicator is a simple mechanism to inform a voice synthesizer that it may want to shift its pronunciation as well. The B element is now used for content that should be set apart, or in the parlance of the documentation, stylistically offset, but it's of no greater importance than the surrounding text. So I like to use it for names of people and products. Keywords would be another option. Books, films, and other media have their own element, which is the site element. Functionally, the B element is a lot like a span, generic phrasing content, albeit with a shorter tag. Now, HTML has other specialized phrasing constructs too, such as ABBR for abbreviations and acronyms. So here we have a ramp embedded in the staircase of Robson Square in Vancouver, BC. The expansion of BC is British Columbia. So you can use either the title attribute or the ARIA label attribute to define the expansion for the abbreviation or the acronym. Screen readers, though, are more likely to read the ARIA label attribute, so that's probably the better route to go at this point. Although if you do want the tooltip, when a mouse moves over it, you can use title as well. ARIA stands for Accessible Rich Internet Applications, and it's a spec that maps complex operating system-like UI constructs into accessible ones. And I'll talk more about ARIA in a bit. Finally, there's the span element, which is used for generic phrases. It's a meaningless element, so wouldn't be spoken in any way differently than the default text surrounding it. So there's nothing particularly interesting about this sentence. Links are also phrasing elements, but I want to call them out specifically because they're a much richer interface and they provide a lot of opportunities for fine-tuning how our users interact with them. The primary way we use links is to connect related content. It's important to choose meaningful words and phrases as your link text, because text that reads generically, like click here to learn more, is not terribly useful, especially if you're using an assistant to read out all of the links on a page, which is a common way that people using headless UIs skim web pages. So here we have the ramp embedded in the staircase of Robson Square in Vancouver, British Columbia again, and Robson Square is the text that's actually linked, instead of saying something like, to see the staircase or the ramp embedded in the staircase at Robson Square, click here. Click here would have been the link, and that would have been not a great link context. It's possible to have your cake and eat it too by including non-visible text within a link. This gives you brief, uniform links from a visual standpoint, which might be desirable, but it also lets you provide context to non-visual browsers as well. So this is an example from my site where the actual text to continue reading a full article from the teaser is finish reading. That's the visible text. But what's actually read out to assistive technology and screen readers and such is you can finish reading The Web Should Just Work for Everyone, which is the title of the article, in less than 10 minutes. So much more context there. But only finish reading is visibly displayed. We can also use links to reference content within the current document, or even at specifically identified positions in other documents. So here we have a reference to a figure that appears elsewhere in the document, and it's just an anchor reference or an ID reference directly to that figure, which has its own unique ID. You can even inform the user about the language being used on a linked page using the hreflang attribute. So in this case, this is a translation of the page into Spanish. And you can indicate the kind of content being linked to. So if it's a direct link to a video file, you can say the MIME type. And you can even inform the browser that you wish for that file to be downloaded instead of linked to, instead of navigated to. This is a relatively new addition to the spec. But it gives us the possibility of doing so much more. And in a voice assistant situation, the voice assistant might say, this file is for download. Do you want me to add it to your Dropbox or your Box account or something like that you have connected? It's worth noting, however, that cross-origin URIs will be navigated to rather than downloaded for security purposes. Anchor elements also support non-web pseudo protocols. Two of the most common are mail-to for email links and tel for phone numbers, but SMS and webcal are also common. Some operating systems and browsers allow install of apps to register custom protocols that can provide access to in-app functionality, but a little bit of a word of caution, unrecognized protocols may prompt the user to search for an application that can actually use it, and that may not be possible in a headless UI context. Now, all of this phrasing content's great, but we've spent a while in the weeds and the minutia, so I want to pull back a little bit and look at documents themselves. As you're no doubt aware, headless UIs place a greater cognitive load on our users. It's hard to keep track of where you are in an interface, and it can be challenging to move around when you can't gather information about the interface based on visual cues. The more complex an interface is, the more challenging this becomes. The same is true in visual interfaces too, which is why the mobile-first movement encourages us to focus each page on a single task. This reduces the noise and raises the signal, but most web pages are the antithesis of clear and straightforward. As our screen sizes enlarge, we found more stuff to fill in that space. Sharing links, related content, cross-promotions, and so on, sometimes it's easy to lose sight of the actual content. To combat this, screen readers provide numerous mechanisms that enable users to gather information about the current interface and move efficiently through it to the bit that's relevant to them in the current moment. One of these mechanisms is browsing by heading. The various heading levels in HTML create a natural document outline, and assistive technologies can enable users to skim content using these headings. Since only the contents of the heading elements are read out in this mode, it's best to avoid cutesy marketing phrases and stick to summarizing contents of a section. Another mechanism available for skimming an interface involves moving the focus caret from one interactive element to another. Traditionally, that movement's done via the keyboard tab key, but it's also possible via voice using keywords like next and previous. In most documents, this means moving from link to link, shown here in green, and supporting skimming in this way makes the text we choose for links even more critical for ensuring a good experience. Form elements and buttons are also focusable, and I'll discuss form elements in a later section. You can also add elements that would not traditionally be focusable into the tab order by adding a tab index attribute with a value of 0 to them. This ensures critical interface components are not accidentally bypassed by users skimming an interface. And then the final way users can traverse documents are via what are called landmarks. The concept of landmarks surfaced in the development of the ARIA spec, and the idea was that you could use the role attribute to define specific regions of a page based on their function. In this example, the author is isolating their navigation in a div element with an ID of nav. Now, while that might be a meaningful identifier for them in terms of CSS and JavaScript, there's nothing that's exposing that information to assistive technology to present this as navigation. Adding a role of navigation, as shown here in green, makes that function explicit. There are numerous role values that are landmarks. Now let's take a look at a few of them in action. Some of you may be familiar with this site, 24 Ways to Impress Your Friends. It's an advent calendar of sorts for web professionals, and it's both highly interactive and highly accessible. They use landmarks to identify all of the key areas of each page, such as the primary header or banner of their site, the main content, content concerned with easing navigation through the site, and information about the content, such as copyright designations. And here's how users can actually experience that.
Main landmark 2015, heading level 1. Navigation landmark browse 24 ways, heading level 1. Search landmark search 24 ways. Content info landmark copyright 2005, 2016, 24 ways, and our authors.
Landmarks also give users the opportunity to jump directly to a location in an interface, which is incredibly helpful. In a voice context, a user might ask their assistant to read me the navigation for this page or search for wooden baby toys, and the assistant can use these landmarks to quickly respond to those commands. Now, it's worth noting that many of these landmarks also have equivalent HTML tags, And this is because HTML5 and ARIA were being developed at the same time, and we're looking to address some of the limitations of the web at the time. Now, as both browsers and assistive technology progress, some of the redundancy won't be as necessary. You saw some of the redundancy in the 24 Ways site, where both the semantic element and the role were used. Eventually, just the semantic element will be able to be used because these landmark roles will be auto-applied to specific semantic elements. One last bit I want to touch on before I move on to discuss forms is the div element. We often see the div employed in web pages when the designer wants to group some elements together, and that's fine. But div is a meaningless element. It adds nothing to the interface in terms of context. By contrast, there are other organizational elements that do add value to a page. We've got paragraphs, we've got lists, we've got descriptions, figures, figure captions, we've got articles, sections, headers and footers, main content, navigation, complementary content. There are a ton of meaningful elements out there that can enable our assistants to do more for our customers. And the more we use them, the more useful our assistants become and the more powerful our users feel. For instance, using article and heading elements can enable voice commands like read me all of the news headlines on the front page of the New York Times without involving any specialized form of data feed. The generic div gets you none of these benefits. As you can see, HTML has a lot to offer in terms of enabling our interfaces to operate effectively in the world of headless UIs. Beyond just content, though, it has the capacity to streamline interactivity, such as the kind we see in forms. Now, forms are a bit of a necessary evil. We need them in order to gather information in the service of our users, but often they're poorly planned and even more poorly executed, which leads to a poor user experience for all of our users, regardless of how they're interacting with the form. Thankfully, HTML has our backs there too, enabling us to make the necessary connections to clarify the purpose of a form and expedite the completion process. But let's start with something simple, field labels. Now, while it may seem perfectly reasonable to mark up form fields like this with text and an input, there's no association of the question, what's your first name, and the text field that follows. To create that association, you need to use a label element. That'll ensure the label can be read by assistive technology when the field is focused. Labels can be associated either explicitly or implicitly. Explicit association relies on the for attribute, whose value should be equal to the ID attribute value of the associated field. Implicit association relies on the label element containing the associated field and the label. You can even combine these two approaches, but in most cases, explicit association is the simplest and clearest choice. Once you have a good label, it's time to turn your attention to the field type. There are a bunch of options available in HTML, and it's important to choose the right one for each job in a form. If you're just looking for a simple response from the user, the text input is your go-to. You can even leave off the type equals text because this is the default input type. If you're asking for someone's email address, there's a special field for that. It looks like a text field, but in browsers that understand type equals email, they can also validate the field for you automatically. But if a browser doesn't understand that field type, that's okay. The field will simply revert to being a text field because that's the default input type. Now, you can and still should validate this field to make sure it's a valid email address on the server side. And we'll discuss that shortly. Now, this is a perfect example of progressive enhancement, a topic quite near and dear to my heart. I wrote a book called Adaptive Web Design that's all about progressive enhancement. And you can actually read the first edition online for free, and it's a progressive web app, which would make Jason happy. And I've contributed 25 copies of the second edition to the Concatenate raffle. So some of you will be able to get that in the next few days. But back to inputs. So HTML5 also gave us a specific field type for entering URLs. As with the email field type, browsers may handle validation for you automatically. There are, of course, a ton of other field types I could talk about, but I only have so much time, and there's a lot more I want to cover. So UX design is often concerned with reducing the friction of accomplishing a task. And as such, we should look for every opportunity to do so in our forms. Consider this form construct asking for a phone number in a US format. This is something we see all the time here in the States. Instead of a single field enabling a user to continuously type their phone number, the designers chose to break it apart into 3 fields. They probably did this to enforce consistent number formatting in every submission. But really, That's a back-end problem. By going down this path, the designers have placed the burden on their users rather than their developers, and the experience suffers for it. Sure, you could write some JavaScript to auto-advance the user from field to field as they type, but without JavaScript, they have to do it manually. And even if the JavaScript enhancement is available, it can limit the user's ability to edit one of these fields if they make a mistake. Furthermore, when it comes to using this interface via voice, users are required to supply 3 separate values. And moreover, each field requires a label. Most developers, even US-based developers, are only likely to know how to label the first of those 3 boxes, the area code. And actual users would be baffled if they were asked to provide their central office code or line number. For all of these reasons, it just makes sense to work with what HTML gives us. There's a field for telephone numbers, input type equals tel. It doesn't validate phone numbers because there are too many formats internationally, but that's okay. It's inconsequential to write code to sanitize and homogenize structured information like phone numbers, passport numbers, and the like. And honestly, we should be writing that code anyway, because you can never trust the client, even if you enforce structure and consistency via JavaScript or markup. And we'll circle back to that idea shortly. Forms can be incredibly frustrating to fill out, especially if they're particularly long. As designers, we're tasked with reducing users' frustration. Now, errors happen, that's a fact of life, but we can help our users avoid errors by taking a few simple steps. Most browsers allow us to store information to be auto-filled in forms. Many also watch for common data to be filled in and prompt the user to save what they entered to autofill later. Some even go as far as to store the values you enter along with the corresponding name or ID value, and will prompt you to fill that information into future forms that use the same name or ID. For this reason, it makes sense to turn off autocomplete for sensitive information like passport numbers. It used to be that all we had was on and off options for this feature, but we've recently been given a bunch of additional values that enable us to get really granular in the kinds of information we're asking for and prompt for autofilling. These values come from a set of predefined tokens, and there are a ton of them. I'm not going to go into every one, but I'm going to walk through a quick example here. So in a headless UI scenario, the assistant could actually prompt a user to autofill these fields or ask which previously stored value they might like to use. Here, I'm using the shipping modifier plus the mobile file modifier, all in reference to the tel token. It makes sense since the label reads, "Is there a mobile number we can reach you on regarding delivery?" So that maps directly over to shipping mobile tel. As I'm sure you can imagine, this sort of affordance can do a ton to reduce the friction of forms. If you're keen to learn more about these autofill tokens, I highly recommend a great blog post by Jason Grigsby, who was just on before me, on the Cloud4 blog that walks through all of these different autofill keywords and other ways to quickly get through forms. So that can help users quickly fill out fields automatically, but what about everything else? Well, first of all, we should always let a user know when a field is required. A common approach is to provide a visual indicator, such as an asterisk, if not all fields in the form are required. But the best solution, honestly, is to avoid this situation altogether by only having required fields in the form. Then you could simply introduce the form saying all fields are required. Regardless of the way you go, however, use the required attribute to ensure users of modern browsers can't submit the form if the field is empty. You should also use the ARIA required attribute, which will inform assistive technology that the field is also required. Not all browsers map required to ARIA required automatically. We should also provide hints as to the type of responses that we're expecting. This can go a long way in helping users avoid issues before they happen. So here we have we're asking for a complicated response, a Delta flight number beginning with the letters DL, followed by 2 or more numbers. We can enforce client-side validation using the pattern attribute seen here in blue, and that's a regular expression. But we can also suggest the kind of content the user should be entering via the placeholder attribute seen here in orange. Now, as you all know, round trips to the server are expensive, especially on flaky networks. And we can help our users avoid this costly experience by validating locally in the browser. Traditionally, this meant using JavaScript, but as I've mentioned, we have a bunch of options in HTML5 that get the browser to do it for us for free. Client-side validation begins with noting required fields. It's worth mentioning also that we don't have a good native solution for choose one or more style checkboxes or radio controls, so you'll still need JavaScript for that. The next step is choosing the right field types for the kind of response that you want. That way you can pick up any native validation that might be available. If native input type for your purpose doesn't exist, you can fall back to the pattern attribute. Browsers that implement HTML5 validation will automatically notify users of field errors inline, typically indicating the first error when the user attempts to submit the form. If you want more control or want to handle the validation in browsers that don't implement HTML5 validation, you can use the declarative instructions provided by the type attribute, required attribute, and pattern attributes to actually roll your own. Just be sure you do so in an accessible way. So in this code example, we're marking a field as invalid using the ARIA invalid attribute shown here in green. And the error message is associated with the field using the ARIA described attribute, which, like the labels for attribute, is an ID reference to the element or elements containing the error message. In this case, the strong element.
Your emails are edit required invalid entry. Your email address is required blank.
Now, eventually, ARIA described by will be replaced by ARIA error message in this context, but support's not there yet. Client-side validation is great, but it's no substitute for server-side validation. Now, back in 2001, when the original Xbox was the game system to drool over, we as an industry put a lot of faith in the browser and didn't really think about how our sites could be hacked. I remember one instance where someone realized a major vulnerability in an e-commerce site, and it involved this very system. In their infinite wisdom, the developer of the site had decided to place the price of the Xbox in a hidden input. Since it was hidden, no one could see it. And sure, an enterprising web designer could view source and see it, but these were the days before browsers had any tool for web developers to manipulate a page in real time. The thing is, browsers still did have a save option to save web pages for offline viewing. And once saved, the file was editable. So Daring Soul downloaded the page and adjusted the price to $1. They then loaded the local HTML document in their browser and submitted the form, which took them back to the original site with the Xbox in their cart for, you guessed it, $1. They checked out and got their nearly free Xbox a week later. The developer had no checks in place to make sure products wouldn't be sold for anything other than their listed price. They didn't realize that you can never trust the client. You should always validate on the server side. Just because a user has JavaScript or a browser capable of doing HTML5 validation doesn't mean you can get away with assuming that validation criteria was met. It's inconsequential these days to change a web page's markup, adjust scripts, or otherwise compromise a web page using only the tools built into virtually every browser out there. And since server-side is your last line of defense against errors and omissions in forms, you need to be prepared to return a user to the form and clue them in on what's gone wrong. Start by summarizing the errors you found. Put a message like this near the top of the form. Start with helpful introduction. List the errors in the order they were presented in the form. Make sure each error provides a convenient link to the field with an issue, and you can actually use the IDs that you referenced in your label to do that. And then add a role of alert to ensure ARIA where browsers read the contents first.
Contact retreats 4 weeks. There were errors with your form submission.
Then use the pattern I showed earlier to indicate in line what went wrong with each field and how to fix it. If the user entered a value, make sure to bring it back so they can correct their mistakes rather than having to start the whole thing over. HTML is a truly robust and expressive language that's often overlooked and undervalued, but it has the incredible power to nurture conversations with our users without requiring a lot of effort on our part. Simply taking the time to code web pages well will enable our sites to do more, thereby enabling our users to do more. Hopefully this rather brief introduction has opened up your eyes to the wonderful world of HTML and how semantic markup can make our content structured, sensible, and more importantly, meaningful. And if you are already a true believer, I hope you'll walk away from this session with some new techniques and approaches you can put to use in your own work. Thank you all very much.
Thank you very much, Aaron.
My pleasure.
All right, okay, so time for questions. Any questions from the audience? At least one question. All right, no questions. Thank you very much, Aaron. Really
yeah, feel free to hit me up on Twitter if you have questions.
Okay,
Thank you all.
All right, have a good day. All right, guys, so we have just one more speaker for the day, and then we are done. I know you guys are tired. You're tired, right? Yeah, pele. Sorry. Do. Okay. Just quickly. So we talked about web fonts the other time, and I don't know what kind of theme that some of you use for your editors, whether it's Sublime or Code. So I want you all to check out this font called Dank Mono. Dank Mono is a coding font actually. It has like is a very excellent coding font. How many of you have used this is another very nice font I use, but I can't remember the name right now. But you should try Dank Mono. It's very nice on Code. It's very nice on Sublime. It also works on Atom very well. So it's designed for. It has ligatures. How many of you know the ligatures? The way or yeah, exactly, ligatures and 8 leaks. So you can try it out. And then yeah. So is Shelly available? Shelly is the last speaker for the day. And Shelly is a data visualization.
Hello.
God, I'm a Yoruba man. Shelly is a data visualization expert, and she'll be talking about data visualization for web developers. So all the charts, all the graphs, all the beautiful things. Shelly, are you ready?
Hi. Wait, let me figure out okay. I think I can start screen sharing.
Okay, we like your monitor.
My monitor?
Behind you.
Oh yes, no, that's my office mates. That's my studio mates. And there's a really gorgeous mural here too. I'm not gonna move my screen too much, but there's a really, can you see it? Can you see it?
Yes.
I don't know.
Oh, that's so nice.
Yeah, I'm surrounded by art and designers and illustrators. It's a really great environment.
All right, okay. So you can start.
Okay. Let me share my screen.
Okay.
Let's see. Okay. Share screen. There we go. Can you see my slides? Hello? Hello? Hello?
We can hear you, Shirley.
Okay. So I guess it's good. Thank you so much. Good morning. Well, hello. I hope you've been having a really great day. Thank you so much for letting me finish off the first day of your conference. And I want to also thank Christian and Sarah and Brian, everybody on the organizing team that I haven't quite gotten to meet or talk to. I want to thank you so much for organizing this and doing this. And I feel like it's something really amazing and something I feel like significant that you've let me be a part of. So I want to thank you so much for that. And I want to talk to you today about data visualization for web developers. Hi, my name is Shirley, and I'm an independent creator of data visualizations. I started out studying business and computer science in college, and when I graduated, I went to a big data company doing front-end development, right when they were trying to move from high charts to D3. And being that new kid in the office, they asked me if I was interested in learning some D3 and doing some projects with it. And I loved it so much that I decided that I wanted to do it on the side for fun. And so I started doing all of these side projects in data visualization. And I loved that so much that I decided to quit my full-time job and go full-time freelance doing data visualization projects. And I've had the most amazing opportunities to work with different companies across different industries, helping them explore their data, figuring out insights to build visualizations around, and building data stories. And perhaps because of that, sometimes I get asked the question, how can I get started with data visualizations for the web? And the answer I usually give is Give yourself a project and practice lots, like lots. But that's a really simplified, oversimplified answer for quite a complicated question. So I wanted to take this opportunity to talk through some of the projects I've done in the past and the lessons I learned from them. So let's start. The very first lesson is about data, and it's that when you're trying to start a data visualization project, find a topic that you're really curious about, and then go out and find the data to satisfy that curiosity. Because that curiosity and excitement will push you through that project and help you finish it, motivate you to finish it, especially when the project gets hard. 2 years ago, I was really obsessed with this one musical called Hamilton. And I was so obsessed with it that I had it on repeat, and I started kind of analyzing the lyrics for themes and recurring phrases. And it got to a point where I was just like, okay, I should just visualize this. And so this is it, an interactive visualization of every line in Hamilton, where every single one of these dots is a set of lyrics sung by a character in the musical, and I give the reader the insights I found with the analysis that I did until they get to the very end, where I give them the full exploratory tool I used to find those insights, where they can, for themselves, filter by any set of characters, conversations, and themes, and dig into the lines, the remaining lines, to do their own analysis. When I started on this project and I was trying to go out and get the data, the questions I had were, how do the relationships change between the characters throughout the musical? And what recurring phrases are associated with whom? And as you can probably imagine, none of this data was readily available out there online. And so I had to go manually create the data myself. And so first, I went through the lyrics. I went through the lyrics twice, actually. But the first time around, I went through the lyrics and noted any recurring phrases. And then I grouped those phrases into themes. And I went through the lyrics again, this time manually entering all of the themes and all of the characters and conversations that happened throughout the musical. And I wrote a script to aggregate those songs by line number until I got my final data set. And this project really taught me, this project and many similar ones, really taught me that as long as I have a curiosity, I can get any data, I can go out and get any data I want within reason and within the law, as long as I'm willing to do some manual data entry or write some automated scripts. So once we have the data, we have to make sure to explore that data before we get started on the designing. This is a side project of mine called 4 Years of Vacations in 20,000 Colors, where I take all of the colors from all of my past trips, I group them into the trip that they were taken on, I arranged them by the day of the trip that they were taken on, and this is one of my favorite projects because I feel like I've learned a lot about myself when I was doing this, which is that at first I was really confused because I knew that when I go on vacation, I really love nature and I love taking pictures of nature. So all of these blues and greens made sense to me because they must be like pictures of waters and lakes. But what I was really confused about was all of these reds and oranges that I was seeing, because I knew I wasn't waking up for any sunrises. And when I dug into the underlying photos, it turns out that these oranges and reds were food pictures. So I really learned a lot about myself through this visualization about how I travel, which is apparently that, for example, this trip to Asia and to Japan, apparently all I did was eat. But this one was to Iceland, and there was a lot of waterfalls, and so there was a lot of green. And I really like this visualization for how much it taught me about myself. But it didn't actually start out so well. It actually started out really, really disastrously, which was that when I got all of the data, and when I had finished getting all of the data and I was ready to start designing, I was so exhausted by just getting the data that I actually didn't explore the data before I started the sketching. And when I started the sketching and trying to design, I feel like I had really great intentions, which is that I was really curious about where and when I took my pictures. And so I wanted to do that where the y-axis was time, so when I took those pictures, and the x-axis was time of day or where around the world. But you can see that there's no hint of me ever actually exploring the actual data set, and there's only a note in here about how to technically implement it. And because of this, this is what happened. This is what happened when I actually plugged the data into the visualization. I like to lovingly, when I plug the data into the design, and I like to lovingly call this man peeing into puddle. And I like to consider this my postmodern contribution, art contribution, but I also knew that this wasn't a good final visualization. So I had to take a step back and go in and look at the data and really ask myself, what metadata does each of the photos have? Does each of the data points have? And when I did that, I realized that the data I had, I knew which trip it was taken on. So I could group each of the colors by that trip. I knew what day it was taken on, so I can actually sort it along by angle, and I can sort it based on the day of the trip. And I also had hue, saturation, lightness information for each of the colors. And so I can sort it along the radius like that also. And that's how I got to my final visualization. And this project really taught me to list out all of my data attributes so that I can assign them to visual channels. Visual channels being things like XY positions, sizes, color, shapes, and make sure to watch out for the extremes also. Now, once we've done the exploration, the data exploration, and we've gotten a basic understanding of the data, the next step is to design a visualization to showcase that data, which to me is one of the hardest things to do as a developer. So over the years, I've created a set of guidelines for myself to help me with the design process. And one of the most important rules in there is to design with a question in mind. And if that question leads nowhere interesting, try a different question. Last year, I had the opportunity to work with Google News Labs and their search data dating back to 2004. And I decided to look into travel data, and in particular, what people around the world search for in terms of travel in different seasons, across different countries, and the topics in those countries and the search interest and thus the seasonality of each of those topics. When I started on this project, I knew that I wanted to do something with travel, but even with that constraint, it was still a huge, massive data set. And so I decided to narrow down with some questions. And the very first question that I asked was this: what is the top search country for travel? And who's searching for that country? And this was a little bit interesting, but not interesting. I didn't find that particularly interesting, other than perhaps the fact that countries nearest to the country in question searched most for that. The countries nearest, the neighboring countries, searched the most for that particular country. But other than that, I didn't find this question and the answers that it gave me particularly interesting. So I decided to change to a different question, which is what kind of topics are being searched for in each country? And this design was really confusing and hard to read, so I tried a different design to answer this question and another. But perhaps it was these designs, perhaps there really was nothing interesting about this particular question, but I didn't find any of them compelling. So I decided to take a step back and concentrate on something else that I had noticed earlier, which is, does geography play a part in who searches for a country? And I tried several iterations of designs to answer this question too, but I was dissatisfied with all of them. And I was getting really desperate and I wanted to find something interesting. And that was when I remembered that I had noticed something really interesting about seasonality in my earlier data exploration. I was wondering if I could do something about it. And initially, it didn't look that interesting until I tweaked my design just a little bit. And there it was, insights. In particular, that at least for people in the US, we search for travel and vacation much more in the spring and in the summer than we do in the fall and the winter. Now, I'm not saying that you have to go through all of this back and forth that I did for this project, especially because it's super time consuming. But I would encourage you to get the data onto the screen as early as possible with software like R or Tableau, or even with D3 and other charting libraries. And that's because, unlike a normal design process, I find that there's no clear handoff between design and code when we're building visualizations. Very rarely can we predict and design exactly what the data will look like on the screen. So make sure to get the data onto the screen as early as possible in your design process. We've talked a lot thus far about how to get the data, how to explore the data, how to design for that data. And now I want to talk about code, which I think is what we're all really, really good at. And I want to talk about how to code visualizations in the web. And you might imagine that that's a little bit different from how we might create a website, in that visualizations is all about drawing shapes onto the screen with SVG or Canvas. And the best thing I ever did for myself is to teach myself SVG paths and get a little bit better with math and trigonometry, because with those under my belt, I find that I can draw any shape that I imagine up in the browser. So this is another one of my side projects called Film Flowers, where I reimagined top blockbusters, summer blockbusters in the last 2.5 decades as flowers, where each of the petals are parental guidance ratings, each of the colors are different genres, and the size and number of petals is their IMDb rating out of 10. And there's some really beautiful ones in here, like The Dark Knight Rises and Inception. I always love Harry Potter, but my absolute favorite that I share every single time is this 1997 Batman and Robin, because of how tiny and cute it is. But when I first published this project, I sometimes got the question of, oh, how long did it take you to do this? Or how hard was it? And the answer is, it actually really wasn't hard at all to draw these. It actually was quite straightforward to draw all of these flowers. And all it takes is an understanding of SVG paths and the cubic Bezier curve command. And I want to show you how I drew this cherry blossom. And I'm going to start with just the petal. And the way that I draw the first curve is, I think of it as starting from a point, the 0, 0, and I draw a straight line and down to the endpoint, the purple endpoint. I then take the blue and green anchor points and I drag them out and I move them out until I get the curve I want. I draw 2 straight lines. I draw the curve on the other side. I rotate the flower petals, add some colors, blurred colors, and that's it. That's all it takes. That's all the code it took to make these flowers. But drawing shapes onto the screen won't give us the whole visualization. It won't help us translate the data onto the screen. And to do that, you might have heard of something like something called D3, a JavaScript library that helps draw visualizations onto the web browser. But you might also have heard that there's a little bit of a learning curve when picking up D3. And that learning curve is usually the enter, update, exit pattern, which is how D3 manages updates to the DOM. But these updates to the DOM are actually what frameworks like React and Vue are really, really great at. And so I would encourage that you use React and Vue and D3 together to draw visualizations, because they actually go really well together. And to show this and how to do this, I want to share this really simple set of visualizations with you where I visualize the weather data of 3 different cities. And I want to actually live code 2 of these with you, this bar chart and also this radial chart. And so I hope you'll be patient with me as I do this, but I want to show you how you can use D3 to draw the visualization, to calculate the visualization, and for React to render them. So to start with the bar chart, our data looks like, our data is for every single one of the days, the data we have is the date, the high temperature, the low temperature, and the average temperature. And these that you see, these bar charts you see are made up of 365 SVG rectangle elements. And to draw rectangle elements on the screen, you need the X position, the Y position, the width, and the height. And so what I want to do is map the date to the X position, the high temperature to the Y position. I want to calculate the height as the difference between the high temperature and the low. And finally, I want to fill the color with the average temperature. And to do this, D3 gives us a really great set of utility functions called D3 scale. So for the x-axis, I want to use D3 scale time, and I want it to translate between the min and max dates to 0 and the width of my visualization. And to do that, I give it the domain, which I calculate as the minimum and maximum dates, and I map that to 0 and width. And then I calculate my Y scale. And I want that to go from the minimum and maximum of the high temperature. Oh, actually, I want it to go from 0 degrees to the maximum high temperature. And I want that to get mapped to height and 0. And finally, I want my colors. And I want to just use a built-in D3 color scale. And so that is interpolate red, yellow, blue. And I want to map that to the min and max of the average temperature. D.average. And so the minimum average temperature will get mapped to the blue, and then the maximum will get mapped to the red colors. And now that we have all of the D3 scales, we can just create an array of objects where each object represents one of the bars. Let's do that. So data.map D. And I'm going to return an object that has the X, which is the X scale, pass in the data, or pass in the date for that particular data point. Y is the Y scale, and pass in the high temperature. Height is equal to the difference between the low temperature on the Y scale and the high temperature on the Y scale, and the fill is pass in the average temperature to the color scale. Let's console log these bars to see that we did it correctly, and pass the bars back as state. Oh no. Okay, so we can't do the color today because it turns out I have the wrong version of D3. So it's just going to be all black bars today, and I apologize. But let's make sure that we have the bars calculated correctly. And here we are. We have 365 objects with the X position, Y position, and the height. And now we can use that in the React render function, and we can just say state.bars.map, and we want to return a rectangle element for each one of them, where we use d.x, d.y, and then the width, let's just give it a random 2, and the height is d.height. And we should see a bunch of, nope. This .state.bars. Oh, I'm sorry. And I forgot to do this part. But now we should be able to see a bunch of black bars that show up. And I apologize for, thank you, wow, thank you so much. I actually haven't been able to see the audience during this whole time, and I'm getting like a little bit sadder and sadder, but I'm so glad to hear that. Thank you so much for that really loud whoop. And that makes me really happy. Okay, thank you. Oh, I'm so happy right now. So that's how easy it was to get these bars. And then let me show you how easy it is to get these axes on there. So now we have to do a little bit of, we have to shift the bars over by a little bit to make room for these axes. So what I'm gonna do right now is instead of mapping to 0 and width, I map to margin.left to give a little bit of room. I subtract margin.right. And I subtract margin.bottom and margin.top. And then you'll see that this should give a little bit room on the left and the bottom. And then I'm going to create a y-axis using d3.axis left. No, so y-axis is on my left. So d3 axis left. And then I'm going to create an x-axis, d3 axis bottom. And then in component did update, and in render, actually, let me do render first. I need to give a group element, and a group element, and then let me give it a ref of x-axis, and another group element, a y-axis. And then in component did update, if I did this correctly, I can just say select the x-axis group element with D3 and call the y-axis, the x-axis that we created earlier, passing in the scales and if I did this correctly, there should be const. Oh, sorry, I shouldn't have const. If I did this correctly, there should be some numbers that show up at the top. Oh no. Oh. I'm really sorry about that. So let me actually move on and show you the radio chart, because I think I'm running out of time a little bit. So please be patient with me. Let me show you how to do the radio chart. Oh. And I want to show you how easy it is to do this also. And so to do a radio chart, what we need is the radius. So I want the date to be mapped to the angle, and I want the temperatures to be mapped to the radius. And then D3 has this thing called an arc generator, where if I pass in the start angle, end angle, and inner radius, outer radius, it will give me back what I need to draw each one of these slices. And so let me go and create the scales. So the radius scale is equal to d3.scale linear, and get the domain which is I want to map it between 0 and 0 degrees and d3.max data and the high temperature, and map that to and map that to 0 through width divided by 2, and I want to do per slice angle is equal to 2 times math.high divided by data.length. And I'm going to try and do this as quickly as I can. And I'm going to, for each of the slices, what I'm going to do is data.map d, and for each one of them, I want to return a start angle which is I times per slice angle, and I want to give it an end angle, which is I plus 1 times per slice angle, and then inner radius is the radius scale of the low temperature, and outer radius is the radius scale of the high temperature. And hopefully, if we did this correctly, I can show you the slices really, really quick. And let's see that we did this correctly. And we did. So if I just map each one of them, to a path element, an SVG path element, and I give it the D attributes, where I should just be able to do this and hopefully get a bunch of black slices. And there we go, there's a bunch of black slices. Thank you so much. And then I just have to put that into the middle. So bear with me as I do this last little part.
Well done, Shelley. My head has burst.
And that's it. And that's it. That's all it took. These are all the lines that it takes to do this. And I just wanted to thank you so much for letting me show you how easy it is to do data visualizations if you do D3 and React or D3 and Vue. And today, I just want to wrap this up by saying, start out small. Start out small, start out with just using React and D3, try out some simple charts. Once you feel really comfortable with that, try creating custom shapes with SVG paths. Once you feel comfortable with that, try recreating a chart with your own designs. And find a curiosity, go out, get data, and explore it. And that's when you'll find with each of these little steps that you can create, that you've created a custom data viz from start to finish. And you might ask, so what? So what? I might not be creating any data visualizations for work, but you might find that if you do this on the side, that you'll start to enjoy and you'll start to think critically about data. And that might be really important in this world that we live in now with so much data. And But most of all, I hope that you'll go out and give data visualizations a try. And I hope that you enjoy it and love it so much that you'll join me in creating custom data visualizations for the web. Thank you.
Thank you, Shirley. That was beautiful.
Thank you. I'm sorry for running over.
That was mind-blowing. Thank you very much.
Thank you.
Really mind-blowing.
Thank you so much.
Let's give her another round of applause.
Thank you. Thank you so much.
Any questions? Maths, trigonometry, React, D3. No questions.
You have my Twitter. Please ask me anything on there.
Shirley, there's one question. We have one question for you.
Okay.
Recommended resources and tools.
Oh, well, actually, so I've actually gotten that same question before, and I've tweeted it before, and I can do that again. But in terms of recommendations for how to get started with the data for data visualizations, I would recommend, looking at the D3 library, what that offers. I would recommend trying using that with React. And I would recommend, after doing that, I think the design part is the most important for data visualizations. So looking at different books about data visualization, my favorite is Alberto Cairo's The Functional Art. And then there's a lot of free resources online, websites that talk about data visualization. And so my favorites on there is Nathan Yao's Flowing Data, Andy Kirk's Visualizing Data, and follow these, get a sense for the design, follow people on Twitter, watch talks from OpenVisConf, and I think if you just kind of keep at it, I think those would be the best resources I've come across in the last few years. Thank you.
All right. Thank you, Shirley.
Thank you. Yeah.
All right. Bye.
Thank you so much. Bye-bye.
That was amazing. How many of you started questioning your programming skills? Because I did. She made it look so easy. That thing is hard. D3 is hard, but she made it look so easy. And then the way she was typing with her, I don't know, that's a mechanical keyboard, right, that she's using? Oh my God. I need to upgrade my hardware. All right. So that was the last presentation for the day. Again, announcement. All right, so again, I said it's like many of the gifts that were given out. We didn't do any of that today because again, I've told you the reason. I don't have to reiterate it again. So tomorrow we'll be here again for the second day, which is the last day of Concatenate Conference, and then it's going to be bigger and better than today because I know like some of the people that could not come because of their work or offices will be free tomorrow to come around. So it's going to be awesome. And then many of the gifts that are available, like all the subscriptions, Egghead, Front-End Masters, Tyler McGuinness, do we have Azure? Azure Storage? Then the books, then GitHub, AceKid. AceKid, you have some GitHub stuffs, right? All right. We have some GitHub subscriptions. We have so many, it's just lined up in the spreadsheet. And we're going to be dishing that out tomorrow. So thank you very much for coming, guys. I really appreciate it. Well, thank you for coming. Thank you for staying till the end. We really appreciate it. So we'll see you tomorrow, same time, same station. Start Zone Station.